I guess it's better, maybe? Okay, we'll see. But now you don't hear me, maybe? Okay, anyway. So, also, yeah, if something doesn't work, like you don't hear me, you don't see something, also stop me again, right? That's important. So yeah, it's dangerous because we might be entering a phase where the role of the researcher is a bit undermined. We discussed this in the introduction session as well. And it's something we need to really pay attention to. We need to really remind ourselves that these are just still mathematical models. They are incredible in what they're doing. They're magic, as Giordano said. They're like wow, as Giordano said. But we really need to pay attention as to the input, the critical thinking we put into it, and the output we get all the time, right? We need to be constantly evaluating with something called human in the loop sort of process. We need to add ourselves, introduce ourselves to all the steps. I spoke with many people yesterday about using LLMs just to do an entire workflow automatically in an agentic way, so you let the machine do the entire thing on your own. But I told you it's much more efficient and much more reliable if you introduce yourself and your input throughout the stages of what the thing you want to do, and not just let it run alone. Before we do any Python coding or anything, I just want to introduce a little bit why these large language models are so amazing, what it is that they are doing a little bit different than what we saw yesterday, and how come this explosion of using AI, artificial intelligence, happened. Like what's behind it. And to begin with, LLMs are so useful and revolutionary because of this basically paper, which was published in 2017 by some people at Google primarily. And it's called Attention is All You Need, with this amazing catchy title. So basically this paper introduced the family of models called transformers. And we could also stop here and say that, okay, transformers is the amazing thing, but I just want to tell you a little bit about it. I mean, their structure is like this, and I'm going to explain this super easy plot today. I'm joking. We're not going to do all of this. I don't even know how to explain. I don't know if you guys know how to explain all of the encoder, decoder stuff. Okay, cool. It makes me feel a bit better too. So no, we're not going to do that. We're just going to focus though on one extremely important aspect in the architecture of this model, this transformer model, which is called self-attention. Jordan, I think you picked up on it a little bit yesterday, but just a tiny bit, yeah. But like the idea is that all the previous models would look at every word individually and perhaps the one or two or three words coming after that, right? That's like the context window of this thing. And every word would be in a sequential manner, one after the other. With the self-attention mechanism, and you guys are free to also intervene and explain something better if you feel like. So the idea is that in a sentence like the cat sat on the mat, the model can look at every word and its connection to all other words in the document, in the sentence, while it's looking at it, right? So first you look at the and all its relations, then cat and all its relations. So in that way, the model can derive separate meanings for apple with a small a and apple with a capital A, like Giordano showed you yesterday. Okay? We don't have to go too deep into this. Because A, I'm not, as I told you, very capable of going much deeper than this. But B, it's because we don't need it at this stage, right? After the introduction of this transformers family, then something else came along, which is the Bert models. Again, with this amazing paper. So by the way, these papers have, I think this has like 150,000 citations, and the other one has like 200,000 citations, something like that, like insane numbers, like incredible numbers. So BERT stands for bidirectional encoder representations from transformers. So basically they took the transformers and took it to the next step, which is how we can use this to train a model like this, a transformer model, to an insane amount of data, right? This model solved we cannot train fast enough problem. We don't have enough time to train our models, right? It would take a long time to digest documents. So this family of models came in and solved that issue. And it solved it with something called masking, which is, this model is filling out blanks. So imagine a sentence like this. The man went to the store to buy some milk. When we train a Bert model, what the model is doing masking. So it, and by we, I mean computer scientists. Not, you will not have to train a Bert model, at least not anytime soon, I think. Maybe you will, but no need to think about it like I'm gonna train this right now. So the man went to the store to buy some milk. The model masks the word went and tries, we mask the word we mask the word went, and we feed the sentence to the model without that word, and we ask the model to guess that word, right? If it guesses wrong, it switches up its algorithm and it tries to guess right the next time, right? And we mask this word, then we mask another word, then we mask another word, and we feed the text to it this way. So the model is much more capable of parallelizing. So this basically is like look, I don't think anyone, maybe I'm wrong, but I mean, I imagine for the majority of the room here, English is not a native language. So when you learn a new language, you do an exercise like this, right? You try to learn prepositions and you try to, she's afraid in the dog, she's afraid for the dog, she's afraid from the dog. So by making a mistake or seeing an example again and again and again, you realize that eventually you should be saying afraid of something, right? So we learn this phrasal verb, or that weeks of the day need a non-preposition instead of an in preposition. So, stuff like that. So that's what the model is also doing, right? When it's learning. And this makes it extremely efficient to read through data and learn data. And this is another thing I stole from the internet for this presentation. And basically what the previous models were doing is going word for word in a sentence. My dog is something and fluffy. And it tried to predict that word based on what's next or what's before in like a sequential manner. So my dog is cute. My dog is tiny. My dog is huge. My dog is whatever, right? But if you see the end fluffy, what guess would you have here for this word? My dog is tiny and fluffy. My dog is huge and fluffy. My dog is hairy and fluffy. Is hairy better? Why do you say hairy is better? Because this is afterwards, right? So this is informing your decision to say hairy instead of just tiny. Or at least say that hairy is potentially a little bit more probable than tiny. It's not about being absolute, it's about having a higher probability. So what Bert is doing is it looks at both sides of the masked word. It looks at both what's going on before and after. So that's bidirectional. That's what we mean with bidirectional. And that, made training insanely much more efficient and scalable. And we were able to read an insane amount of text and have these incredible models. And Bert revolutionized also how we use these models in machine learning and NLP and what we try to do. So there is a foundation model, one that has been trained by Google or organizations with that capacity to train models and have access to data also, because access to data is very important. And then from that thing, we can take that foundation and we can build specialist things for the things we want to do, for the tasks we want to do, right? So you can get a Bert model and you can get a medical specialist by just fine-tuning, which is something we don't have to discuss now, but it's something you do when you want to get to a more specific thing with this model. So you can have a finance specialist, a legal specialist, etc. And it's sort of like a paradigm shift for what we do. So before Bert, for every task we had to do, is it sentiment analysis on political text? Is it any prediction task we wanted to do, who will vote what? We would have to build our own custom machine learning architecture from scratch. That's extremely hard to do. It takes time, it takes skills. But then with Bert and these large foundation models that you can take and tweak to do your own thing, we move to something like you have a universal foundation that can adapt to most things because it has world language knowledge, right? Does this make sense? Cool. So sometime here, just before 2017, the transformer models came, and this is like the evolution of the transformer models. Again, I stole this, I didn't make it. An insane amount of models came out based on the transformers architecture. Right now we are down there. Actually, we're way past there. There's GPT 5.2 now. There's Gemini 2. I mean, many things. But you can see like the amount of models that is created. And these are all foundational models that you can take and use for your things. And obviously this, from Bert, we went to LLMs as well, right? I don't know if you remember this. We showed this in the introduction session. Those of you who were there. It's how an LLM works, which is trying to predict the next token. An LLM is yet another family of transformer models that, I mean, again, we don't have to really go into that because we discussed this a little bit, but the idea is the following. Especially the chatbots you interact with. Yeah, the large data, Giordano? Yeah. Come again.
No, so much more parameters, but in the end it's...
Yeah, it's the same thing, but yeah. But in the end, yeah, much bigger, like the word large there, yeah. The thing is that the models you are interacting with, the chatbots, Gemini, ChatGPT, and the ones we are going to interact with today, because we use the word models a lot, right? But the chatbots you are working with are doing this thing, which is based on what you typed in the prompt and you hit enter. It looks, it tries to predict only the next token by calculating probabilities of what's most probable to follow the word my dog is, right? So you type my dog is, and then it calculates probabilities for what word should come out of its dictionary of words in broad terms. Right now, there are performance metrics about models out there. There are leaderboards about models. So if one clicks on LLM stats, for example, sorry. You have like a leadership based on some metrics of their performance. GPQA is a common metric, but you have other metrics like how humans evaluate it. These are standardized metrics of like tests we give these machines to pass and or fail, and they get scores. So right now, GPT 5.2 Pro is apparently the highest performer in this metric. And as I showed you before, you can see that this is based on this same metric, GPQA. You know, the score from 2023 from these models is going up, but I don't know if you can see it. It seems like we are also getting into some sort of like plateau, where the increase in performance, so from 3.5 to 4, the increase was high. GPT 4.0 was extremely high, but then you will see that the performance gains are plateauing. So these companies cannot anymore offer the same amount of performance gains in every iteration as they did in the beginning. And a very crucial thing here is the distinction between open and closed models. Anybody aware of what a closed proprietary model is versus an open model? Yes? Would you like to say?
I think they open sources to us because if we wanted to use for our own project, right?
Yep, okay. You're kind of right, but you're only 20% right. So there are 4 more elements that you're not accounting for. So when we looked at this leaderboard, there is a license column here. I mean, there are many leaderboards. This is just an example that I'm showing you. There are other leaderboards as well. Hugging Face has its own, and I'm going to show you that. So there is a license column here, and if you see that it's all closed, there is one open here. Kimi, Kate, I don't even know it. It's from China, and it's open. There's another one open here, again from China, GLM. So it's kind of important to speak about the distinction about what is open and what is closed sourced model. So an LLM like Gemini, a chatbot like Gemini, and the model behind the chatbot that you're interacting with, an LLM like GPT-5 from OpenAI that is behind ChatGPT when you use it and you ask stuff, is a model owned by a company. It's owned by OpenAI. That means you are allowed to use it, but you probably need to pay for it. And not only that, you do not know how it was trained, what kind of parameters they used when they were training it. You're also not capable of, if they decide to stop using a model, or there's another word for taking it out of action anyway, decommissioning a model, if they want to set it aside, you have no longer access to it unless they give you explicit access to it, right? So you are bounded by the rules of the proprietary owner. When we talk about open source, on the other hand, so something like Hugging Face that Giordano showed you yesterday, this amazing repository of community, they say, of models about many things, machine learning models about many things, including large language models, including Bert models, like we saw yesterday. They are a repository of open source models, and we will see what that means. But the idea is that anyone can just take that, read the documentation, download it in their machine, and do stuff with it without asking explicit permission. Maybe some open source models have some permission things that you need to sign and some agreements that you need to sign, but the idea is that you can take it anytime and use it for whatever purpose you see fit, okay? Also, it means that you know how it was trained, you have documentation about the model, you know what, who trained it, on what machine, and that means that you can also maybe replicate the way it was built, right? That's extremely crucial for science. So we are meant to be doing science in a replicable way, in a way that others further down the line can use the same tools to replicate what we did and confirm or say that what we found was not right. That's an extremely huge and important part of doing science. So you need to keep that in mind. So
also, I think it means that you can also be part of the community of developing them.
Mm-hmm. So anyone here in this room can take a Bert model, fine-tune it on a particular social science task they want with their own data, like Turkish social media or whatever, or Arabic social media. And then you have a fine-tuned Bert model that does one very specific thing in Arabic social media. You are most likely going to upload it here with its documentation on how you did it and how useful it can be for that specific task, so that other people can take that model and use it again or build upon it and continue with that, right? That's the idea of an open source model. The open source initiative has created a definition for what is open source. The open source AI definition 1.0, I mean, this is almost a year long now, and I kind of feel like that maybe they're not as active as they were before. Do you agree, Andrea, as well? Yeah. I mean, this looked very promising initially, but I'm not entirely sure if they are as yeah. Anyway, so their version of what an open AI model should be is basically this thing here. I'm going to try to zoom in a little bit. So an open source AI is an AI system made available under terms and in a way that grant the freedoms to, 1, use the system for any purpose and without having to ask permission, study how the system works and inspect its components, modify the system for any purpose, including to change its output, and share the system for others to use with or without modifications for any purpose. So a model to be called open source, it needs to do all of these. Although many of the models we are going to see on Hugging Face are open source, in fact, they don't fulfill all of these criteria. So a model like Llama, for example, from Facebook, is a model that, I mean, is open source. You can use it for any purpose without having to ask permission, although you have to tick a box that says that you're not going to use it in this and this and this way, like making money or something like that. But you're not really able to study how the system works and inspect its components like the same way as you would do another model. So some models claim open sourceness, but they're not in fact. And I also have like a table here on the slides. I don't think we should go through all of this now, but I'm going to leave it here, which compares what are the benefits of closed versus open LLMs. I just want you to see for a moment this important thing, which is hardware requirements. So you have all been working on Google Colab for this workshop, and you interacted with some LLMs also, some models yesterday, and we are going to interact with models today. A Google Colab notebook is running online. It's not running on your machine. So the resources, the processing unit, the RAM, the memory of the machine are not being used. You're using someone else's memory. I will share the slides. They are on day 5 folder, so you're more than welcome to see. So you don't have to be taking pictures. I mean, up to you, eh? No problem. So when we are using a proprietary model through some service provider like OpenAI, we have no hardware requirements because we are not. So you could also do it on your phone, right? Via your phone on your browser. So you don't need a good computer. When you run open source models and you download them in the machine and you're running them, you need potentially very capable machines to do some of the really high-end level things, right? And this is something important. Another important thing is, remember, privacy and compliance matters. So when we work with online services, we sort of lose full control of what is being happening to our data. Our data is being sent to some server elsewhere. Whereas when we are working with an open LLM, we have full control over the data. Everything stays local. It is very, very important. So anyway, I'm gonna leave this here. We can discuss this later if you want to go through it. I'm also leaving you here on the slides if you want to learn a little bit more about LLMs, a couple of concepts that are sort of key. In my eyes, two incredible YouTube videos, very short, very succinct, explaining what LLMs are and how they work. They are incredible in my eyes. You should take a look at them. This is all on the slides. You can use them later. Remember, there is also the limitation slide about hallucinations, the sensitiveness of prompting. We're going to play with this today. The environmental impact and the cost. Do not forget about this stuff as well. But I don't want to go through them again. So yeah, I think we should just now go into doing some cool stuff with an LLM. Okay. So by show of hands, who here knows today what an API is? This is like,
I'm looking at you.
Andrea, this is like a test of whether Wednesday when good or not. Okay.
Sorry, Jan.
Yes.
Before continuing, I don't know if you're planning to say later. Can we briefly spend a word for defining what is an hallucination? Because maybe now we are all familiar with that, maybe not.
Okay.
And I think it's crucial in LLM.
I'm gonna show by doing hands-on, but I think we should do it. No. What you are missing, Giordano, is that we we did an introduction session. But the good point is, did everyone attend that introduction session in this room? Is anyone here in this room that did not attend that session? Okay. Should we go over hallucinations once more?
I don't believe we need to.
So we have one strong no and one strong yes. Is there anyone to break the tie?
Yes.
So strong yes? Okay. So sorry, we have to go very, very briefly over it, okay?
Take a break before that?
Yeah, a break? Is it time for a break?
No. I mean, when you explain it, I take a break. 2 minutes. Just shortly.
So hallucinations are something these models do by nature. Majority of these models we are going to see, large language models, they were trained to, as we said, they were trained to predict text, right? To predict what should come next after the thing. So they are generative by nature. They produce something out of nothing, right? And they base their answer and the way they produce their answer based on tons and tons of data they've seen. So if that data, for whatever reason, does not contain relevant information for what we are asking, or something close to what we are asking, so that the model cannot infer something correctly, it still has to generate a response. Like, its job is to generate something, right? So if the information is not there, or generally in any scenario where the data is not strong towards one answer or another, the model might give you an answer that it does not correspond to the truth. So we call that a hallucination, or it's not really necessarily connected to the truth. A hallucination is just something that is either unexpected, a bit more creative, a bit more different than we as humans would expect. Hallucination is to see something where there is when there is nothing, right? But we speak about hallucinations as something like very bad, but actually it's a feature of these models. So we're going to show you later, by tweaking some parameter, how you can use the hallucination feature as an advantage, to your advantage. So in broad terms, this is how I have hallucinations in mind. Giordano, is there something you would like to add that's useful for them?
Just to review the answer. I mean, don't trust LLMs.
All right.
Because
Yep.
they hallucinate.
Yeah.
So they can pretend to be overconfident on something, and then they make mistakes. So
Yeah.
But most of the time, like with larger models, if you ask them, do this, and if you don't know the answer, please tell me, or ask me questions to refine my query, they will somewhat be more precise. Not all the time, so still review things.
So and one more thing. So especially ChatGPT, but other chatbots, they've been fine-tuned to be polite, agreeable, and these companies are optimizing their models to get more engagement, so that to get more of you and more of us to work with these models, to speak to these models. That's what they get money from. So they are optimizing their models to be on things that they surveyed and they think are important for us. So sometimes, I don't know if you've seen that, but you get two answers and they ask you to choose one of the answers, which one you like. That's the company asking you what you prefer, so that they can continue building models that do more of the thing you prefer, right? That's problematic for many, many reasons. But one of the things that's problematic for is that you get a model that keeps agreeing with you when you ask something, and maybe you don't want that. So you need to be aware that you need to somehow control it by prompting. And that's like the only way you can control something. Also some parameters that we will show later, okay? But now we're gonna do the cool stuff. Any other question at this point? Okay. So, no, by cool, I also mean it's not going to be difficult. I promise. Today is not going to be difficult. So, this is ChatGPT, right? You've seen this. You type something here, blah, blah, blah. You hit enter. This goes somewhere to a server. Some LLM behind it is generating a response, and you start seeing the response, right? But this, as we said, is just an interface. It's just a front-end thing. You are not actually sending the response to the server. You're just hitting enter, and it's happening behind it. But you can programmatically do this too. So today we're going to do this programmatically. We're going to do this with Python. Before we do that, we need to have access to OpenAI's API. So you raised the hand about what an API is, and I'm glad. So what I would like you to do, so you do not have to do this because so what is the number one thing we need when we want to access an API service? Key. Great. We need an authentication key. We need something that tells the service that it's us, that we have rightful access, or we have paid, and it's not someone else. So my program now interacting with you, sending you this request, is my actual program from this person that has the account and it's legit. Please give me access. So we need that authentication key. So I would urge you to create your own OpenAI API account right now, but you do not have to do this because I will provide you a key for today, at least. So if you want, we can all go to OpenAI API. So it's platform actually, but you can also type OpenAI API. Come on. Mac is not collaborating.
I don't know if it's happening for you, but the Wi-Fi on days.
The Wi-Fi is not working?
No, I mean,
It's kind of important.
it's very slow.
What's with this thing now?
I like to share my data with my phone, so I couldn't open the presentation.
Okay, we have a couple of issues. One is that my Mac, for some reason, has this stupid window here.
Do you need adapters or?
No, it's working. Okay, we're gonna have this here. If it bothers you, you tell me. It's gonna be down there at the bottom. So we go to API platform, OpenAI, and you need to log in or sign up if you don't have an account. So if you can do that now, it would be great. You can use your Google account. Yes.
Same account with ChatGPT?
No, this is a good point. So this is not the ChatGPT account. So now we are in the API platform. So we are going to interact with the services of OpenAI. So this is not ChatGPT, it's not the same account. But you're welcome to use the same Google credentials that you're using for that. So if you go to sign up, you can use Google. Does anybody need help with this? Like, yes, or whatever credential you want. I mean, it's up to you. You can create an account from scratch with another email. Eh?
But it gives a few options: ChatGPT, API platform, Codex, or which one?
ChatGPT, no, not ChatGPT. API platform. We are in API platform now.
No, that top right left there. Yeah. Which option of this?
But the problem is that I have an account already, so I'm signed in. So I didn't have the sign up button. So anybody needs help again? I'm gonna give a few moments for you to do this. But eventually you should log into something like this. You should have your face on the top and top right corner and etc. Anybody needs help? Remember, you do not need this. I have a key as well to give you, but it's just good for you.
It's okay to sign in with an institutional address?
Come again?
Is it okay to sign in with an institutional address?
It's totally up to you with which account you connect. Just use some credentials you want. I use my Google account, but you can use whatever you want. This is signing up to a service as you would sign up to any other service online, right? So you have an API account.
Let me just.
So when I tried here, it says
Anybody need help or wants?
so it says that the account already exists, even though I only have ChatGPT account. I never.
Can you accept this?
Sure.
I think it's a notification, maybe.
Supposed to be.
But I guess you don't have internet now? Is the internet better, Giordano? Is the internet better? The Wi-Fi?
I think it is.
Yeah, but some people are having issues.
Now I'm connected to EduROM, and EduROM is slightly better than the YADESA, I think.
Okay. I'm on EduROM too, actually. Did you manage?
I'm trying.
At the moment you click this, you're in. Sure. Okay? But you call me again. Who has not logged in? Who has not logged in on the OpenAI API? Only one person, I guess? Okay, cool. So let's go get a key, okay? Sorry.
I think right on top, right?
Is it? So if you go to the search bar and you type API keys, there is, no, we are not on ChatGPT anymore. So are you here? Are you on this page?
Left column, there is a API keys option.
Where is it? I mean, I expected to see it, but I cannot see it.
It should be there.
Yeah, but anyway, it's not a problem. I can search here, okay?
We can just click on that also, right?
Yeah.
You have permission to view and manage API keys in this project.
Yeah.
It's on the dashboard, by the way.
Was it?
Right on the top dashboard.
Thank you.
Now you have API keys on the left.
Bravo. Good job. Okay. So everybody's on the API keys screen? Okay. So you go on the top right corner and you click create a new secret key. You give it a name. Test, YADESA, it really doesn't matter. The name doesn't matter. So I'm just gonna name it YADESA test. And I will click on create secret key. And now the API key is generated, but remember, if I click on done, this is like my only chance to copy the key. After that, I won't be able to see it anymore. So you click copy here, and you click done. And now it's copied and you can go and paste it in your code, paste it on wherever you need to paste it. If you can all open the Google Colab notebook for today, it's on day 5.
I'm sorry, can you repeat the point where we put the key?
Sure. Are you on API keys? There is a button on the top right corner. You click that and you give it a name. Whatever name, it doesn't really matter. You're never going to use the name. It's just so that you can, this is just if you have multiple keys and you want to know which one to use where.
Which part should go in notebook, part 1 or 2?
So part 1.
Part 1.
So in day 5 today, in the folder, there are 2 Python IPy and so notebook files. Just open part 1. Anybody needs help up to this point? So you have your key copied? Good job, guys. So on the left here, we are navigating in our file. Just we are gonna do Bert topic later. Go to text annotation right away. Can you see from there? Of course. That's actually exactly what I want you to tell me. Like, Yanni, wait, I didn't do this. Tell me what's going on. Like here, how can I do it? Okay, we have time.
So we have the key. We go on day 5, and what do we do?
Come again?
We have the key. We go to day 5, and what do we do?
I'll say that once they get. What's the problem?
I'm unable to create a key.
Don't worry. I'll give you a key. Yeah, don't worry.
Can you show again the steps?
I don't think on this laptop we see the dashboard.
So are you on your OpenAI API or platform? So it's platform.openai.com.
Yeah. Then we can go on API, right?
So you can click on dashboard, top right corner dashboard.
Okay.
You got it?
Found somehow.
Yeah.
There. Okay.
Oh my God. And all right, guys. So now open the Google Colab part 1. Everybody opened? Everybody here? So here. On the left, there is this navigation bar. Skip the Bert topic and click on text annotation right away. It will take you to that part of the script, okay? Is everyone here? Yeah. All right. So there is a box here that says Open API key. You replace the X's with your key.
Inside the quotation mark?
Yes, inside the quotation mark.
It seems to be too long.
It's okay. It's very long and weird numbers and letters. Not weird, ASCII characters.
Press play.
No, wait. Everybody copied their key in there?
Yes.
Who needs help? Final offer. I'm moving on. 3, 2, 1. Okay. All right, guys. So remember one important thing. Google Colab is amazing. It's great, especially for settings like this where we are learning together and we are all working from the same on the same stuff, but everybody has a slightly different computer. So if we were to install Python in our machines, everybody would have to do a slightly different installation of Python, slightly different libraries, slightly different things. And in the end, especially for contexts like this with 60 different laptops, it creates many sources of problems, right? So we use Google Colab that I create and you can use, but remember 3 very important things. 1, this is not running in your machine. This is all happening in Google servers right now. So everything you see here the moment this tab closes, the moment the connection is lost, the moment you refresh the page, it's all gone. Well, there are some exceptions, but in the majority of cases, you should consider it's gone. So yesterday, people were creating files here, and they could see them here, but these are not in your computer. These are on Google server still. So you have to download this file to your computer if you want it saved in your machine. If you were to be working with Python locally on your machine, you would not have to worry about this, but this is very important, okay? Then the second thing that is important, this is a Google Colab notebook that I think you've said this before, but I'm going to repeat it. This is a Colab I created. So I can only make changes to this. When you open it and you make changes, if you refresh it, you're going to lose all the changes, okay? So make a copy of it and work on a copy of it if you want. Otherwise, you're going to be seeing what I want. Don't make a copy yet. Just wait a little bit. Yes? Okay, no problem. With a copy, let's work on the copy. It's okay. No worries, no worries, no worries. But you'll see why I wanna create a copy. So, bravo. But I'll show you why you need my key first. Okay? So let's all start with installing OpenAI, the library that we use to interact with OpenAI's API, and a library called TikToken, which I will explain later why we need it. So just click play on this cell that installs OpenAI and TikToken.
Sorry.
Yes?
Can you make your screen lighter?
Of course. Thank you.
And zoom a bit.
Light.
No, John.
Background white.
It's on night mode.
Night mode, yes.
Yeah, it's that one.
I want to look cool, you know? Bro. I want to look cool. Is this better? Great, guys. Do this. Just stop me and tell me what's not working if you can, or like anything, okay? Everybody install this stuff, right? So we can toggle this window to not bother us anymore. Just click on that so that I hate noise, right? So it's better if we have that. So let's import the libraries we need for what we're going to do today. Like, I don't want to explain what they are, just hit play. Pandas you've seen, JSON-L, some people seen it, seen JSON lines file, TQDM, no, don't worry about it. So we did this step already of creating a key, so we don't have to worry about this. So you've done this, and you pasted your key here. So the number one step, as I said, is authentication when we're using API, a service. So it's a way for us to tell OpenAI that, hey, it's us. The way you do it, normally in most cases, is this thing. You create a client object, and in there you put some function from the OpenAI library. In this case, it's called OpenAI with these capitalizations. I don't know why they do that. So I create a client object with this function, and I put my API key in this argument called API key. You can click on play here. So now when we do stuff, we will be invoking this object, we will be using this object called client, and the service will know that it's us with this hugely long key, and we are legit, and etc. So if you click on simple documentation, it will take you to the OpenAI platform where it shows you step by step how to interact with the API. How billing works, we're gonna go through some of this together. How to write basic script to do stuff. There's a lot of documentation. We're not gonna go through it now, but it's there for you to work on, okay? So the way we replicate what happens here when you type something and you click enter is all in these lines of code. Barely 6 lines of code. So what we do here is the following. We create a response object, and on its right, so what this is the following thing. We just have it in rows, but it could be like one line, right? So we create a client, we use the client, object with function chat completions create. That's the function we create we use to interact. So, but you don't have to worry too much about the details. 2 arguments, model and messages. The model argument is where we specify what model we want to use, what model we want to ask OpenAI to use to give us the response we need, okay? When you're on ChatGPT, you have a selection of models up here. Right now it's 5.2 because I have a Plus account, etc. Blah blah blah. I have auto instant thinking. You can have these parameters in your request as well. Okay. You have legacy models like 4, 5.1, but up to 4.40 is what it allows you to do in ChatGPT. But if I go to OpenAI and click on models, I actually have many more models, including legacy models, which are not used anymore, like O3, like GPT-4o, and even older models like 3.5. So 3.5 is discontinued actually, but one of its versions, this one, is still there. It's still available for us to use. We are going to speak about pricing and cost in a moment, but you need to think that higher number version of the model, better performance, higher cost, okay? So this is going to be a trade-off we're going to be grappling with today. So we selected the model, and then the messages, we need to create two roles. There is a system role and a user role. And the content of these two roles, on the one hand, is, in this example, you are a helpful sports assistant. That's the system prompt. What this model should think is doing, okay? On the background. And then the message from the user, this is the actual thing, the actual prompt we are sending it. Who won the FIFA World Cup in 2022? So please all click play on this. Wait. Yeah. And everybody got this error?
There's no answer for me.
No what?
No answer.
But did it run? So you got a tick mark?
Yeah.
I got this error.
Okay, so everybody got this error, right?
Yes.
We need this error. Well, we don't need it, but you know, it's part of the process. Yeah.
But someone in that particular got it right.
So maybe they used my key?
Because of money?
Huh?
Because of cost money?
Yeah.
That's okay.
So you have already, yeah. You're cheating, you're ahead. Okay, so everybody should get this error. Well, I shouldn't, but anyway. Well, we'll see why that's happening. So you getting an error code, by the way, while you're working with Python, you need to start sort of reading the error box slowly, not immediately, but you should start thinking about reading the error. So here, the model, so Python is telling us what's wrong, and it's telling us that there is a rate limit error here. So error code 429, blah, blah, you exceeded your current quota. Please check your plan and billing details. For more information on this error, blah, blah, read the docs of Platform AI. So this means I don't have enough money to pay for the use of the OpenAI API, okay? So what you should do, not today, at some point, is go to Models AI and go to, try to find billing. Yeah. Yeah. But don't worry about it, don't worry about it. Just look at me, look at my screen now. You don't have to do it, look at my screen. So, yes, money, money, money. So, the way it works is that you prepay, you preload your account with money, and as you use it, it uses money from your account, okay? When you reach 0, it's gonna throw you that error over there, okay? So I have $100 US now in this account, and that's for this course so that you can use this. So you are all gonna be using my authentication key, and as you use it, you're gonna be charging my account. That's fine, that's fine. That's part of the course. Just don't be extreme about it. No. So the thing is that when this reaches 0, it will stop working anyway, okay? So if you are, let's use GPT 5.0 in this insane amount of data all together, maybe we're gonna run out of money soon.
So how fast is it, what is the frequency that it throws out?
We'll see. I'll show you. I'll show you how as we do it. So I know you created a copy of the notebook, but give me a moment to create a new key, and I will put it in the Google Colab that I created. So you open that, you refresh that one again, and you will have my key. So you can copy that and continue. Okay. So I go to API keys. I create a new key. Well, actually, I think I have it saved. I thought I had it saved. No worries.
We need to copy and
Right. So if you refresh the Google Colab part 1 now, you should have the correct key. So copy that. Listen, you don't have to select this like that. You can write. So there are 3 dots there. You can do copy cell. Go to your notebook and just Control V or Control C or right click paste, and the cell will be pasted there right away, okay? Yes, you need to go to my original Google Colab, open it, and my key is gonna be there. You create a copy if you want. You create a new copy. Or you copy the cell, it's up to you. If it's not clear, let me know. So open my Google Colab account, my Google Colab document, part 1. It's in YADESA, day 5. You need help?
Yes. So the key is going to be there now.
So go, you can...
Which one? This one?
Yeah.
Paste. Okay, then this one.
Okay, you can refresh it once. Just hit refresh just to be safe. I think internet is working a bit slow today.
So we go to text annotation.
Yes. Text annotation.
And there's a key here. Is that your key now?
If you just refreshed it,
Yes.
it's my key.
Okay.
Yeah.
So you see again, APIs are everywhere.
So everybody opened it again, created a new copy again. Anybody needs help? Going 1, going twice, going 3 times. Yeah, you got me. Yes. How can I help? Tell me.
No.
This is important.
So
Yeah.
sort of. Okay, this time it seems like I'm comparing it with.
But you can't compare it. It's like 50 characters long.
From the beginning.
In the beginning, it looks very similar. But okay. If you are sure, it's good.
No. This time
But you can be sure that because it's my code, the moment you refresh it, it's always the same. So you cannot mess with it.
you can run it.
So if you does that make sense?
Yes.
Okay.
Thank you.
Okay. Now you need to run this cell again with my key now, right? Everybody got a tick mark here in their copy Google Colab? Looking at everyone. Okay. Perfect. So let's try to do this message again now. Let's click on play once again. So now it worked. No rate error because I have money in my account. The model, when it uses it, charges the account, and it's great. Okay?
How much left now?
You're rushing. Wait. Still a lot. But okay, let's check because you're curious. So we have this billing tab, right?
But we just asked one question. How much?
Yeah, but one question times 60. right? 60 people ask the same question. Take a guess, take a guess.
1 cent maybe?
1 cent for 60 answers? It was 101.29, I think. How much?
$100.
Ah, so $1.60. $1.60 for one call, okay? Anybody, any other guess?
Depends on tokens.
Huh. Smart. It does depend on tokens. It does depend on the length of the thing we're asking. It depends on the length of the thing we are sending and the thing that it creates. Both lengths matter, but we're gonna go there. But let's see, this is a small answer. I'm just telling you. This is a small question, a small answer. And 60 is not enough. And GPT 3.5 is a very cheap model. Very old one, not very old. I mean, it's like 1.5 years old or something, like 2 years old. But it's an older model, it's a legacy model, and it's extremely cheap. So you guessed it's finished? Oh. It got up, no. I guess it was 69, 101.69. So all these 60 requests cost 20 cents, okay? So there are 2 reasons why someone would get, so I would urge you not to continue clicking on play. Otherwise we're gonna have more, but wait. It's okay. Someone got an error again, but I don't get an error. So there are 2 reasons to get a rate limit error. Rate is either because rate means the amount of things passing through something, right? I'm really not explaining it well, but yeah, so something like flow, right? So the API services need to limit their flow, otherwise their servers would crash. So if 60,000 people send 60 million requests each, maybe the server would not be able to handle that. So they impose some rate limits that go beyond money, beyond cost, okay? It might wanna say, okay, I'm gonna limit a bit how many times you can ping the server and ask for stuff, okay? So we created a response object, and inside is the answer that the API sent back to us, right? The answer that the server sent back to us lies in this response object. So if you click play and see this response object, it looks like this. This is JSON, and it's not super readable to the human eye immediately. But the answer to what we asked is somewhere there. I don't know if you can see it, but the answer is here. The FIFA World Cup in 2022 has not taken place yet. It is scheduled to be held in Qatar in November 21, December 18, 2022.
It stops at 2021.
In your case.
No,
So
why is it not taken into consideration in 2022?
it stops by, sorry, we'll do all of this.
Okay.
That's a great question. But first, let's try to extract this answer, okay? We don't have to explain this, but this is an easy way to print a JSON response. It looks like this, a bit more human readable, right? Tell me.
It says, I'm unable to provide real-time information or updates. You can easily find the latest updates on the FIFA World Cup 2022 winner by checking the latest.
Excellent. We'll discuss about that as well. So keep these questions, please, for just a moment later, okay? So you run it again, there's an error? I think you're using the wrong key. That's probably the reason. Giordano, just go to my Google Colab, refresh it, and I think it should be fine. Also, if you click on this button now, we go to this exact place where the answer is. The answer is under choices, under message, under content. Is everybody looking at me here? Choices, message, content. So again, you don't have to learn this, but I'm just showing you how you can access this. So I'm doing response, choices, the first object, message, content, right? Just following that path in the JSON file. And I click here and I get exactly the answer that the model gave me in there. Yes?
So why initially give an error and then not shows the answer? What was the reason?
What, so can you repeat?
No. So we asked in the second time after you use your key.
It worked.
It work, but initially we get the answer, it says because the match hasn't played yet.
Okay, that's not an error. That is not an error. That is a response.
Yes.
That's the model generating a response for you.
Okay.
Whether we like the answer or not is the second part. But it's not an error. Is it a hallucination?
Yes.
It doesn't know the answer, and it's not telling you France won it. It's telling you, I don't know, I don't have the answer yet. So this is OpenAI trying to mitigate the hallucinations and asking the model that when you don't know the answer, try to say you don't know the answer. But this, you cannot guarantee that this is happening. Also, we know that the final happened, right? So it should know. So what happened? What happened?
I have a
Yes.
Why have we indexed the choice at 0 when it's actually I mean, like, I'm confused why you didn't index it at 0.
So choices has one, well, in this case, choices only has one object inside. I could have just not specified, but
So we could have
yeah. It's just that it's the first object inside the choices dictionary. Yeah, actually it's a list. So this is a list.
Yeah, because it's only one.
Yeah. It would have worked without the 0 as well, but don't worry about it. Yes.
So in the first case, when we use the model 3.5, we are getting this kind of a response. Then if we go down, we're losing model 4.0. So my question is like, if we use the previous models for generating, does like previous models, if we use an older model to, for example, know about an updating information or a recent event, the models do not work?
So did everyone hear this question? So the question was, let's say you have a task that requires up-to-date information, right? Like, how can I rely on a model that does not have the up-to-date information, right? But that's a super valid question. But it's a question about the type of task you want to do, right? I don't know what task really requires fact-checking, up-to-date, current information, right? Some tasks do. But how companies like OpenAI and people using LLM mitigate this is by allowing LLMs to access the internet in real time, okay? So if you go on ChatGPT, if 3.5 was available here and I selected it and I asked who won the cup, I would get the same answer. But if I clicked on the plus sign here and say, there is internet search somewhere, no? Well, I think now it's baked in, but I mean, there was an option here to activate internet search. So the model would generate an answer after also having looked online a little bit and included that information in the prompt. Okay? Does that make sense?
So they don't update information. So then the model is like.
All right. So this speaks to one of the main limitations of LLMs, which is their training data. Training data have two problems. One is the fact that they have a cutoff date. So I collect data today on the 6th of February, and I start training a model today on the 6th of February. The model does not have data past the 6th of February, right? So it knows stuff up to 6th of February. So if I want to have a model that is updated, I need to continuously retrain a model, continuously build a new model. And every time this costs a lot of money, obviously, and it's not as easy. So what we do is we mitigate this by giving it current information if we need that. In the use cases I have used LLMs, I did not care about present day fact checking. I did mostly historical stuff, and I was okay with that. But if you want to do something like what was contained in the Epstein files or whatever you guys are trying to do up there and there, maybe it's not exactly what you need. But there are ways to mitigate this. So as you correctly saw, this model, because the cutoff date is earlier, does not know exactly what happened. And for every model, you know exactly what the cutoff date is. It's in the documentation, okay? So, I think it's time for a break, but let's do this, okay? So if we swap the model from GPT 3.5 to GPT 4.0, come again? It still doesn't know it?
No, it knows it.
Ah, it knows it. You can remove the max token things, but because I want to explain it later. Everybody run this? And you got the correct response? Yeah. So you're a helpful sports assistant. Who won the FIFA World Cup in 2022? Now I added this thing here that says respond with just a country name. Have you tried removing that and see what happens? So remove that part, run it again, and hit on play again. Argentina won the FIFA World Cup. They defeated France in the final, which ended in a 3-3 draw after extra time. Argentina won 4-2 in the penalty shootout. Thank you, ChatGPT. I only wanted to know who won the cup.
He told me Argentina won, that's it.
Yeah.
Okay. With 4-0. Everybody used 4-0. Okay.
I only also got Argentina. Did we have to change something?
No. Yes. So here, I removed that part.
Yeah, we did.
Okay.
So, what's going on here? Everybody is getting a slightly, or not super different, but slightly different answer, right? That's because the model is generative. The model is creating something from scratch, and it has been set to tweak its responses every time a little bit because it's working on probabilities. Remember, this thing. Guys, listen up. One moment and we take a break. That's the last thing I'm going to say. For now. Remember, for every word, it's predicting the probability of the next based on the rest, on the previous, right? Then it creates a word, so it calculates probabilities, it picks the most probable one. Then for the next word, it calculates again the probabilities. Sometime, when it's calculating the probabilities, the second word will be a bit more probable than the first one, for whatever reason, because this is probabilistic stuff, okay? It's a matter of chances. If you roll a dice 10 times, sometimes you're gonna get heads, sometimes you're gonna get tails. If you roll a dice 10 times, are you sure that the person up there rolling the dice 10 times are gonna get the exact same dice throws, right? It's similar to this. Probabilities matter as to the response, but we can tweak probabilities, and we're gonna do that after the break, okay? Is there any burning question right now about this for now?
I have a question.
Yes, Sumi.
So the model is not trained to create something original, slightly original for each user. So it might be affecting, right? Rather than the probability only.
It can be tweaked to both be creative and be deterministic. I argue that for us, when we do data annotation, we want to be deterministic. We want to be sure that the same model annotating the same text over and over again, it will give you the same response back every time. Otherwise, we are not doing data annotation, we're just doing creative writing or something like that.
Also for the reproducibility.
Yes, for reproducibility as well.
Once everything you do is probabilistic.
But there are cases where you want creativity. And we're going to do that after the break, okay? For now, let's stop here. Actually, before we stop, just very briefly, let's check the money.
Why do you check the money again? The word Argentina as an answer. Is that also probabilistic?
Yes. But let's get back to that after the break. I'll explain again. So, if I go to usage, so platform, OpenAI, organization usage, you don't have to go. You will see the use of the models in real time. And you can see that in February 6th, we used 7 cents of a dollar. So all the things that we did up to now costed 7 cents, okay? Giordano was very, very kind to remind me that actually something changed in the policy of OpenAI, or I don't know if it changed, maybe it was like that from the beginning, but actually older models, lower performance but lower cost, and newer models, better performance, more cost, is not always true with regards to cost. So right now, some of the older models might be a little bit more expensive to use versus the newer ones, because OpenAI wants to give you an incentive to drop them and use the modern ones. So there are some pricing. I couldn't find the specific model pricing page.
Sure, on pricing OpenAI.
Yeah.
And then there is like more details.
Ah, bravo. Good.
Yeah. Here you have all the table.
So yeah, you have the cost here. Remember, and we are gonna think about it a little bit more, you are getting charged on two main things: input and output. So when you are on ChatGPT, like this, when you start typing, that's the input. You hit enter and the model starts producing an answer, that's the output, okay? The length of both matter for how much you end up paying. Both how long it's the question you're asking, so it's good to be thinking about making the answer as succinct as, the question as succinct as possible, but there's also an incentive for you to make the model be succinct in answering. Can you think of why the size, the length of the input and the output matters for price?
Yes.
Yeah?
Because it will increase the thinking capacity of the, whatever machine they are using.
Yeah.
It will be harder to make harder.
Harder to digest the answer that's longer, the question that's longer.
But also the answer you said is because of the tokens, tokenization.
Come again?
The tokens.
Yes.
Tokens, that's more work also for the
It
machine.
Yes, so
will be more processing time and
so the moment you start typing here and you hit enter, many things happen, including tokenization, but other things happen as well in the background that we don't know, in the back end. All of these steps, the longer the question is, the longer they take. Also, the longer the response we require, the more computation power it takes, the more power, electricity, like real stuff. So it costs more to them to produce the answer. It costs more to the machine in terms of resources to produce an answer and digest an answer. So that's why we are getting charged for the input and the output. And we are getting charged by tokens. You remember what tokens are?
Yes.
So tokens are what we turn text so that models like this can understand the text, right? It's splitting it into chunks that the model can make sense of, that they are then turned into numbers and things are happening with them, right? So a sentence like, what's on the agenda today, might be like, it could be words, but they're not exactly words. So one token could be what, one token could be the apostrophe S, one on the agenda today, and the question mark may be another token. So a sentence like this could be 1, 2, 3, 4, 5, 6, 7 tokens, something like that. So if I were to ask that question to ChatGPT, it would be 7 tokens long, and I would be charged. So this price is per million tokens. So you pay $1.75. You would pay $1.75 if you used GPT 5.2 and you asked questions for that were 1 million tokens long. Does this make sense? So if I were to type a question here, that's 1 million tokens long, and hit enter, I would be charged 1.7, no, not on ChatGPT, on the Pythonic way we're doing, right? Not here. Here you don't get charged because you are either paying for an account or you use the free account. So if I were to type a message here that was 1 million tokens long and hit enter, no matter the length of the answer, it would be already $1.75 every time I clicked enter. That's a lot of money, right? So we need to think about that. Also, you get charged by the output. So the length of this answer matters as well. So if we go to pricing again, if we go to pricing again, there is the output as well. and the output is extremely more expensive. So if we requested an answer that would take 1 million tokens to get, it would be $14 every time. 1 million tokens, by the way, is not that crazy, right? It would be what, like, okay, let's ask ChatGPT. So how long in words would 100 pages? Would 1 million tokens be? 750,000 words? That's actually a lot, man. So
that's good then.
depends on the language too, right? Depends on the type of tokenizer, which is important, but yeah.
Think about Chinese, like every word is a character.
Yep. Bravo, bro.
Every word is a token. So every character, every expression, everything is a token. So you can that's probably more efficient actually, because like
Chinese is more efficient.
Chinese is more
Yeah.
efficient. Costs less,
Sure.
because like for instance in Italian we have like a word that has a root and then it has a gender and the number of
Yes,
like a
yes.
singular and plural. So like that, those are different tokens.
Yeah.
But
Good point.
Chinese doesn't have like verb forms, so it's just
Yeah.
one token, so it's compressed.
Yeah.
So ask your questions in Chinese if you know it.
Great. All right. So we're gonna see cost a little bit more later on, but so there are a couple of parameters that we can pass here. Sorry. That we can pass in here that can help us tweak this answer. One of the ways we can tweak is by succinctly, like specifically, explicitly asking the model to be brief, okay? So in this case, I'm specifically asking the model to respond just with a country name. No more fluff. So I click on play and I get the answer and I get Argentina. Just Argentina. It's the answer I wanted. I didn't want all the rest, okay? And I forced this by this. But now remember, I added 1, 2, 3, 4, 5, 6 tokens to my input. But my input is much less costly than the output, right? So it's better for me to do it this way. Also, according to Giordano, putting you on the spot here, GPT-5 Nano, is like super cheap. So 0.05 cents per 1 million tokens. And GPT 3.5 that we are using, well, it's not here, or it is. Yeah. Might be cheaper anyway.
If you compare with GPT 4.0.
Yeah, we're using 4.0, so yeah. So that's okay, that's a good point. So we are using 4.0 for some questions and we're getting we're paying 2.5 every time for 1 million tokens, so it's not that much. So instead we could be using 4.0 mini.
It's like 500 times. No.
Okay, it's a lot, but we can go with 4.0 mini. So instead of 4.0, you can all swap and go with 4.0 mini if you want, but that's not really important. What was important is the following. So remember about probabilities, right? Remember about this thing. I'll just say it once again. I think it's super crucial to understand. So, because I got some questions. So every time the model is calculating some probabilities and it's picking the most probable word and puts it there. If you roll a dice 10 times, are you 100% sure that you will get 5, not a dice, a coin, sorry. You flip a coin 10 times, are you sure you're gonna get 5 heads and 5 tails? No. But if you do it on a very long observation, anyway, in many observations, you're gonna get it. So that's the same thing here. So if 60 people in the room, if 100 people in the room here ask the same thing for the LLM, maybe after a while, the model is gonna pick the lowest probability of words. So for example, if it calculates that one word should be 80% probable and another word is 20% probable, if we run them all 100 times, 20 of those, it's gonna probably pick the least probable word. Does that make sense?
Yeah.
What that means is that if I put as here, which is a bit less probable, so 7% of the time, the word as should follow instead of a dot. That means that after I pick this, and the next loop starts for calculating the next one, now we have a different thing to calculate. So choosing the less probable word is gonna downstream affect the rest of the calculations for probabilities as well. That's why some of you asked the same question like me, but got a slightly different answer, at least on the long one. I can argue that if we run this many times with the response with just the country name, and everybody runs this tens of times, we are all gonna get just Argentina in this case, because I guess the probability here of Argentina following is gonna be almost 95 or like 99%, so it's very improbable to pick something else. That's why it picks that for some reason. Another thing, the reason it generates the word Argentina is because it has seen in its training data thousands upon thousands of sports articles, for example, that wrote Argentina won the 2022 World Cup. So it has seen many sentences like that. It masked in its training the word Argentina, so it knows that winning the World Cup 2022 was very commonly followed or preceded by the word Argentina. So that's how it knows that Argentina is the most probable thing to say here, and it picks that and it generates that as a token. Does this make sense? So if someone, and we had this discussion in the break, and I think it's a really cool thing, if someone in the data set created an equal amount of documents of sports articles that said that Colombia won the World Cup in 2022, and we fed that to the machine would calculate this as 50-50 Argentina or Colombia. And that's what we call bias in the training data. If something is in the data and the model is trained on the data, it's going to be reproduced in the probabilities of producing this text afterwards. Is this clear?
That's very problematic.
There are ways to mitigate it. So Giordano said that there are actually attacks, cyber security kind of attacks right now, where people just push fake articles about something in large quantities. So then in the next iteration of training the models, the people that collected the data include this fake thing inside. And then the model that was produced with it has this fake thing that was in it.
And with more and more AI generated.
That's another problem, of course, yeah. Yeah.
But if I could add something very quickly, like this kind of biasing things could be also potentially good in a way. So if you think about, there was a case where image generation models only generated images of white people when it was associated with the word rich. Okay, so if I put in the model a lot of images of black rich people, then it will be more likely. So this is not maybe reflecting reality because I'm biasing it a bit, but it depends on the world the word of image I want to give to the model. Okay, so I bias it to have something that maybe in my view, according to my ethics, it's more balanced, it's better. But of course you can attack it and you know. Sorry.
This question might be a little bit more advanced from what we are doing right now, but it's something I really want to know. Like right now what we are discussing is the current model of AI, how it tries to make sense of an answer by probability scores and just using tokens, etc. But currently we are also discussing about a future where the AGI, artificial general intelligence models, will also come into play. Are there any plans to change this system altogether, or will it be something similar but much more advanced, where it is like very close to what we consider human intelligence?
Look, I'm going to give an answer. You can then feel free also, guys, to give an answer as well. I mean, we are basing all the things that we're doing today and what we have with ChatGPT and all this potential we have on a very specific way of using these models and a very specific technology of models that is relying a lot on training data, and it's reaching a plateau. We are getting, unless some breakthrough on the training of data or the digestion of data, I don't see how this technology is going to reach general artificial intelligence, right? Like,
artificial general intelligence.
it's the same thing. I feel like it's going to be a change in the system, in this system particularly, but I don't know if you have an answer. I don't have an answer to this.
No, I don't, that's
We have no idea, basically.
The scope will expand then? Like rather than the method, maybe like the scope of computing? Because like there's a lot of fear towards both AI and AGI, so is it based on like actual researches that clearly show a much more, let's say, threat level design, or it is just a lack of knowledge of people which just see this and see, okay, this is like human intelligence, so this might be completely shunned or whatever it is.
But does it feel like human intelligence to you?
Like ludditism is still current in the contemporary world, so like the idea that fearing technology is prevalent. So
Go ahead, Giordano.
I'd like to take this question just to tell you that I attended some artificial intelligence conferences, some of the biggest in the last year, and they speculate a lot about this. They are discussing a lot. Some of them says, oh, they are just parrots, parrots not that try to mimic the language, so they are not intelligent. This is not human intelligence. Others says, oh, we are very close in reaching the AGI. So, I mean, we are at the frontier of the research in this. So, depends on who asks you. And so there isn't an answer actually.
Okay.
There are just speculation. And I mean, I don't know if you ever heard about agentic AI. So that one for me is really incredible, but I don't know if it's AGI or no.
So a guy that I don't know if you value their opinion, I don't value their opinion at all, said that artificial general intelligence could be achieved as soon as 2026. It is 2026. This doesn't look like, I mean, this is Gemini producing the answer, but I mean, he has shifted this timeline a couple of times, so it all sounds speculative to me. I don't know, you guys. I mean,
it's also like it's a very like epistemological question.
Yeah.
Like, what is intelligence?
Yeah,
so
true.
You could argue
Good point.
that intelligence is just like human intelligence is just a very refined network prediction. I don't agree with that, but you could. There are arguments.
Yeah, boiling down, human intelligence is about pattern understanding and prediction, right? So much of the things we do in our brains is about seeing patterns and reproducing them. And text is just, language is a pattern as well. So that's what, but
maybe this is just our best way that we could come up with
replicating
to approximate that process that's happening in our brains.
Yeah.
I don't know.
I just wondered that when we are talking about predicting things from the text, if you came along with any kind of model which is more trying to understand emotions or expression,
So I know that prediction does not feel useful right now, but just give me 5 more minutes, 10 more minutes to see what you can do with this prediction, including estimating emotion. I'm not sure exactly what you have in mind. Is it just positive, negative? Is it sentiment stance? Is it emotion like joy, fear? Yes, we do that with LLMs.
But for example, now in many countries at airports they have visual readings of the faces. For example, when you are entering the country, they read it, like not only detecting people,
Right.
but anxiety, nervousness. So accordingly, they check them. So somehow, like.
So that's. We are working with text here, translated into tokens, but then images, videos, so frames, which are images. So video is a collection of frames of images in pixels. They're also transformed into embeddings, like we did yesterday with text. They carry meaning, and we do object detection on those, and we get a face. And then on those faces, we do another kind of object detection, which is there a smile there? Is it a frowning? Is that, so I don't know who does that right now.
A face mask.
Yeah, some sort of, face mask. Yeah, they are models like that. I mean, they still do prediction. It's still a prediction task. Is this a smiling face or a crying face? That's a prediction task. Is this text carrying fear or joy? That's a prediction task. Is this text for the government or against the government? That's a prediction task. Does this make sense? Everything is a prediction task with artificial intelligence. That's the way we are building them. We are building them to try to predict stuff. We just change what we're trying to predict every time. Question? No. All right.
Yani, I'm sorry.
Yes. Don't be sorry.
Look, for the listener.
But just try to speak up so that everybody hears the question.
Yeah, I waited for so long. So, like, you said that the system uses the probability, right? Like, when answering. Isn't there any way to restrict this? Like, for example, at this point, or?
So, there are two ways to try to change the way the model answers. So, to try to give it a different type of answer than we want, or try to force it to always give the same answer. In this scenario with Argentina, it's a bit easy to have the model give the same answer all the time. But in another scenario, it might not be. So there are two parameters we can tweak. One is called the seed. So we have the OpenAI cookbook here that you can click on. And it has a lot of information about how to use models with posts from people on how to do prompting better, how to do many things better, okay? And it includes stuff like the two things we're gonna speak about now. Seed is a parameter that is either, it's a number or nothing. So you either put it there or you set a number. And I don't wanna go too deep into this, but if you specify a number, the system will make a best effort to sample as deterministically as possible. So it will try to calculate these probabilities with the same starting point all the time. So to try to help you understand this, when you ask a computer to give you a random number, how do you think it picks? So let's say I asked you guys from 1 to 100, pick a random number. How do you pick?
Probability.
What probability?
They just say a random number.
You just say a random number. You think of a number, you say it. Machines do not think. Yes?
I think they just give us the number which they see most in the dataset.
Is that random? Not LLMs, computers, not LLMs. We're not talking about AI now. Humans are primed as well. By the way, there is research saying that nobody picks 1 and 100, or like very few people pick 1 and 100. Like in our brains, we don't think 1 and 100 is very random. We think randomness is more towards the middle, and not 50 for sure. 50 is never random. How can it be random, right? Anyway, machines do not do that. Machines need to pick a random number, but they also, how do they pick a random number? Excellent. They check at the clock. So they use the clock, and they use that as a seed that tries to create a new calculation of probabilities for numbers. And based on that seed, that calculation probability just gives you a number. So when you, come again?
What does that mean?
Yeah, I will show you what it means. Have you ever seen a Galton board? Have you seen this before? Anyone? So the idea is no matter how many times you do this, it's gonna create a normal distribution. Like every time I throw this, it's gonna create a normal distribution. Sometimes maybe a few balls are gonna be a bit here than here, but always this is gonna be higher than this very end one, right? If you run it multiple times. Why does this happen? Because when you throw a ball on the top, and it hits the first pin, it can go either left or right. It's 50-50. But then if it goes left, it's again 50-50 to go left and right. But to go from left to left to left to left to left to left to left, the probability goes very low, right? So it's much more probable that a ball will go right, left, and end up in the middle than going left, and ending here. Does that make sense? Yes. So the Galton board, no matter how many times you flip it, it's going to always try to produce something, it's going to always produce something close to the normal distribution. So the seed, you can think of the seed as where we drop the thing on the top. If I move it a little bit to the left, then the whole distribution is going to the left, the whole distribution is going to shift a little bit to the left as well. So a seed is like where we start this randomization process. And if we always start it from the same spot, we can hope that the distribution is going to look the same in large numbers. That's the best I can do with seed. Does it make sense at all?
How about the clock?
Yeah, I mean, don't think about it too hard.
Yeah, but I mean, it checks the
So when you go to Python code and you ask for, guys, how do I ask for an NP random? Something like that?
NP.random. And you have to import NumPy first. Otherwise, it's just import random.
Zaten bir number uçanmasın.
I guess it's random.random.
Yes? Let's ask Gemini, guys. Come on. Come on.
You just need the bracket.
Who's better, Giordano or Gemini? How do I make it integer?
Gemini, sorry. So ask Gemini. I tried my best at it. Okay.
What? Yes, guys, yes. One moment. So every time I run it, it picks a different number, right? But the way it's doing that is by the seed for it is the clock.
It doesn't make any sense.
Can you guys explain it better? I mean, okay, it doesn't matter. The way is that, the thing is that it doesn't think of which number is more probable like you do. Oh, okay, I'm going to pick 20. I ask you again. Oh, now I'm going to pick 68. The randomness starts with a probabilistic distribution, which doesn't look normal all the time. And that distribution is impacted by, so it's impacted by the clock. But imagine, so from 0 to 100 is easy to think, but like 0 to 1,000,000 is harder to do a bit better. The point is that if I set the seed here, right, and I put a random number, what?
After 0, 0, 1.
How does that impact
What we are doing?
machine dealing with information?
Well, the fact is that
This is probabilities, right? So the model calculates probabilities every time it tries to predict the next word. These probabilities depend on the text on top, but they are not always the same. That's what probabilistic means. So these models are probabilistic. So every time I'm running this, there are going to be slight changes to these percentages based on all the training data.
I'm trying to make it more deterministic.
If I set a seed prior to this calculation, these are going to look more similar every time. I just want to show you what the seed does in NP random. So
dot seed,
dot seed?
np.random.seed.
Anybody knows? Giordano, Andrea?
It should be np.random.seed. Put this. So with NumPy, it's a different command.
And no run int.
And then you
Bravo, Sumaya. Good job.
So basically, the seed here is not for only for decode, but for all the libraries.
I set the seed and then I ask for the number.
Yeah, this one.
Okay. So now fuck this. Just print stuff. So this is how we did it before. I comment out the seed. So every time I hit this now, oh come on, Google Colab. So every time I run this, the number changes, you see? If I activate this, I comment it in, and I set the seed, look what's going to happen now. Sorry, what is your name?
Mehmet.
So did you see this?
No, I missed it.
I'll do it once again just for you because you asked the question. So if I do this again and again and again without the seed, the number is always is different. If I set the seed, the number is always 37. So it's no longer a random number. It's a random number calculated by setting a seed in the probabilities before. So it will always be the same.
So basically, is it about like, since it's 33 cast 9, it's about like something around 30? Is this why you said it's related to clock?
Let's forget the clock. Let's forget the clock. Let's forget the clock.
Because I was asking the
Let's forget the clock.
Right,
Let's forget the clock. But are we a little bit clearer on the seed impacting how closer to always the same probability distribution we can have?
I am not exactly clear. For example, I wrote 5 for the seed and it gave me 99, and I don't know the relation between 5 and 99, for example.
No, there is no relation at all. The
Yeah.
seed has no meaning. It's just you choose a number, the one that you prefer, your lucky number, and then you fix the condition, and then the computer starts to give always the same results.
Okay,
But
so
there is no meaning with the seed. Okay.
So think of it like a black box that always applies the same calculation. It's a computer that is applying the same mathematics to the same number, so it always gets the same result.
So seed is something that I use to fix my number.
Yes. Yeah. So once you set a seed of 0, or computer scientists like to do 42 for some reason. So what they do is the computer applies some mathematics on that number, that 0, and always gets the same random number. What you feel is random is actually, for the computer, it's always the same calculation to the same number. And the randomness is simulated by not fixing a seed, but using this point in time.
Actually, the actual second is the seed. Yeah.
And how does that impact an LLM in the way it answers?
So we are back to this.
Okay.
This is always a probability calculation. And when we start the probability calculation, something like this, the starting point, if we always make it the same, is gonna look as close to the same every time. If we move it, it's gonna be a little bit to the right, so different probabilities. So if we set the seed, we ask the model every time to have the same starting point to calculate the probabilities, not change the starting point.
It's like if I show you 3 cards and I ask you to pick one. Okay. When you fix the seed, you pick always the same card. This is it.
Okay.
How does it impact our research? I mean,
Yes,
Then,
Can it answer my research question?
No, I'm wondering, does it fix a truth somewhere for...
It does not fix a truth. What it does, it increases the likelihood that we will get the same answer if we ask the same question. Bottom line is that if you set a seed and you don't leave it random, you are more closer, one step closer, to always getting the same answer when you ask the same question to the same model.
And who sets the seed?
I do, in the call of the model.
But if you don't, the clock will be different.
Forget the clock.
No, I just got my answer.
You did?
Yeah, I asked it, like
If I set the seed, the clock is dished. It doesn't care about the clock.
Yeah, I mean, I got it now.
But if I broke the clock to always show 9 p.m., I would still be setting a seed.
Yeah.
Just 9 p.m.
It says that.
Yeah. So, but forget about the clock, please. I think I confused you more than I.
Please understand that we're trying to look from the receiver end for us using these LLM systems. What does it mean?
Yep.
This is what we're trying to do.
What it means is this. So first, it means that determinism is not guaranteed.
Okay.
Like this is not like a fix that makes everything perfect. It's just, as I said, a repeated request with the same seed and the rest of the parameters should return the same result. So you're moving closer to something deterministic. When do you need determinism? Can you think when you need determinism?
Analyze the emotion, the truth, for example.
I heard many things. So imagine the following scenario. You have 1,000 parliamentary questions from politicians in a parliament, right? And you want to see if a question says something negative about the government or something positive about the government. And I ask Soumeye, I ask Giordano, and me myself to annotate this, code this manually, and put a value on the side, 0 for against the government, 1 for the government, and 2 I don't know, right? This is how you would manually annotate code data before, right, in social sciences. This could be sentiment, this could be whatever, right? We three do it together. In an ideal world, we would all put the same value there. Let's say now we have a fourth column next to us, which is an LLM, asking an LLM to do this for us. Hey model, is this question for, against, or you don't know about the government? And the model adds its answer as well. We want that model, every time it sees the same question, to always say the same answer. We don't want it to start being creative, to start hallucinating. We want it to give us the same answer. We want determinism in a coding scenario, which we will do.
Basically, we don't want it to hallucinate.
In this scenario.
Yeah.
When we write and we want to do creative writing and we want to summarize text, that's a creative process. We want it to bring new words and not write the same stuff all the time. There we want it to be more creative.
But also because if I do the annotation today and then I repeat it tomorrow,
Bravo.
I hope I receive the same answer, otherwise I need to repeat I need to write a new paper anytime because I have new results anytime. Instead I want to have one fixed result. That's the idea. And if someone is going to repeat my experiments, should obtain my same results.
There is a more intuitive, so Sid, think about it like this. Do I want determinism? I set it. Do I not want determinism? I don't set it. It's as simple as that. Let's go to a more intuitive parameter, which is temperature. Well, intuitive, let's see. Temperature is another parameter. And it ranges from 0 to 2. 2 means maximum creativity. 0 means minimum creativity. So you're asking the model to be more creative or less creative, okay? What it does actually is when the value is higher, it increases the likelihood that the model will pick the less probable words. So when we increase the temperature, we make the model more probable to pick something that is less probable. So it ends up, and because we said that downstream picking one less probably is going to impact the next one, then picking again the less probably is going to impact the next one, it means that we end up with very different answers. Let's try to do this. First of all, let's go with the deterministic, okay? So GPT-4o mini for everyone, I hope you choose that. You are a helpful sports assistant again. Who won the FIFA World Cup in 2022? We set the seed and temperature to 0. Remember, 0, less creative, 2, maximum creative. And I hit enter here. I play this. Look at this answer again. Argentina won the FIFA World Cup in 2022. They defeated France, blah, blah, blah. This victory marked Argentina's third world title with their previous wins in 1978 and 1986. If I run the same cell again, with the same seed and the same temperature and the same exact prompt and the same model, well, I don't have the same model here, I should get the same answer again. The exact same answer, word for word. Try running this. I think it's the exact same answer. Is everybody getting the exact same answer? Some people have changes in the answer?
Words, but initially, for instance, the results in the years, they remain the same.
But you have some changes, but that's a change. So this is not identical to that. So how many have non-identical answers? Has everybody run it?
I did, but it changes.
So you have a different answer as well. So out of a room of 60 people running this at the same time, only 4 people got a slightly different answer. So remember, determinism is not guaranteed, but we got super close. This is like 95% of the cases they got the same answer. So we are closer to determinism. We haven't solved it. Does this make sense? Let's see what happens if we remove the seed and put temperature to 1.6.
What is the highest temperature?
2. Try with 1.6 first. Already the answer is very different. I mean, it's telling me the same answer because, as I said, Argentina, this is an easy answer to give. Argentina won it. It's super, extremely probable, so there's no way to tweak it to give it a different answer. But look, this is totally different than this. It's not the same. Not in content, but in style at least. Now try to put it at 2 and see what happens. Most often than not, it's gibberish.
I got a less detailed answer with 2.
Really?
Yeah, that's
Okay.
interesting.
The thing is that if everybody puts 2 here, I guarantee you that we will get 60 completely different answers.
Still loading, let's see.
Yeah, mine is also going slow. Maybe because with 2, it like messes up, you know, how, like again, remember, it's a downstream path. So it predicts the word if, and then calculates the probabilities for the next word. It picks a lower probability word, then it calculates the next, and it becomes harder and harder as a task. Yes?
Does temperature make sense when you have a seed? Like if you put temperature to 0 or 2 when you have a seed, let's say 50,
It doesn't go to 3. It's 0 to 2. It cannot go higher.
No, I
Sorry.
know, but like when you have a seed, when you have a fixed answer, your creativity doesn't matter. Because
It matters. Both matter. Both matter. Because the seed is where the probability starts, but then the probabilities are still there.
Okay.
Temperature is about picking something that is a little less probable than the super probable one.
So even though it has a less room to play, it still has an effect on
Yes, it does. Yep. Both are very important. Is everybody stuck on this? Because mine is stuck.
Yeah.
Let's try with 1.9. 1.95.
Mine was not stuck. Mine went fine.
And what did it say?
Gave an answer. It added it 1 2 word approximately.
Okay. But nothing crazy. Sometimes when you set it to 2, it also does some gibberish stuff. Maybe not GPT-4o mini, but it will pick words that are completely unlikely and it will end up saying something weird. I think the question we're asking here is a bit easy, so it's not a problem. What's the question?
I think.
So with 2, with temperature 2, with temperature being 2. So your colleague here got a completely gibberish, not a gibberish answer, but multiple languages for some reason.
With temperature 2, I didn't get any gibberish, but I got fake answer.
Fake answer?
Yeah, because it says the victory marked Argentina's 3rd World Cup title, which was actually the 2nd. And then it says having previously won.
No, it was the 3rd.
It was.
I think it won 1978 and 86.
No, it won 86 and 2022.
Okay.
That's what it says.
So that's also wrong.
Yeah, so it says won 1978, but 78 was Brazil.
So they only beat once with the hand of the god. No worries. No worries, no worries.
So Yanni, is it wise to use something closer to 0 or exactly?
Depends on what you want to. Oh, I would go with 0 if I want determinism. So in the annotation task we're gonna do, the coding task we're gonna do, I go with 0. So the prompt and how you ask stuff matters a lot. We discussed this a little bit. and I'm gonna leave you here a prompt engineering guide about making prompts a bit more efficient. So there's the OpenAI prompt optimizer, where you can type your prompt here, choose the model you're working with, and then OpenAI will tell you how to fix this prompt and make it more efficient. This can be very, very useful. And I mean, I'm just leaving the links here, and you can always try all of this in the playground. So playground is sort of like an interface for the API where you can play without coding. So you can pick the model from here, even the legacy ones. You can also tweak the parameters here. You can tweak temperature, etc. So you type a message here, then you type the prompt itself, and you see if the answer is always the same or not. So there's an easy way to play with a prompt here instead of doing it programmatically all the time. But then when you have to do the task that we will do, you need to go to programming, you need to go to Python. But I'm just leaving all the links here and you can play.
I have a question.
Yes.
So let's assume I want to make data in a different language. In terms of prompting, is it better, like would it be better for me to prompt in the language that I want the data to come out in, or should I write it in English and specify that I want it in that language?
So a model like GPT, especially these latest ones, 4 and 5, they can get input in one language and output in another language. They're capable of doing that. They can digest Turkish and respond in English. It's not a problem.
I mean, in terms of prompting, is it better to use English and then specify that I want the results in another language?
I don't have an evidence-backed response, but I would say that English is probably better for prompting. Yeah.
There is some evidence that English is better simply because it has seen more text.
Yeah.
So it knows that the association between those words is better.
And in a scenario where prompting really matters for cost and whether the output is the one you want and to be deterministic every time, then I guess it makes sense to prompt in English. Good question. Guys, I have an exercise here for you now. You should spend the next 10-20 minutes on this. And I have the following question. So there is a prompt here. Classify the sentiment of the following sentences as positive, negative, or neutral. Okay? And I have a set of example sentences here. This is what we call a naive prompt. It's not very efficient. And you can go and try to make it better. You can play with the seed and temperature here and try to get the same answer for the same input all the time. Try to play a little bit with this on your own. Try to move these sentences here in the user prompt and try to get the right answer. So for example, there are some ironies here hidden in this text. So I just love paying extra fees for services I never asked for. Right? I mean, this is a negative sentence. But there is irony here, so maybe the model is going to pick positive. So try to play with this and see if you're going to get the right label here out of the 3. You can play with this model or get a better one like 4.0 mini. But spend like 10-15 minutes, maybe 20 playing with this. If someone has a question or wants some help, do it. Please let me know. Should I come?
There's an error, I don't know.
You have not. Can you read the client, the error message?
Name client is not defined.
Okay, so you have not defined client. Where did you do the definition of client? You remember?
I need to define here?
No. Where do you see client?
I don't remember.
Do you see client somewhere in the text?
Here.
Okay. What is this thing? Do you remember? No. Go higher. Go higher. All the way to the top.
Parameters.
A bit more. A bit more. A bit more. A bit more. Here you are. Do you see client here? This is where you define. So for some reason it lost this. Either you refreshed this or the connection was lost. So it says that the client does not exist anymore. Please set the client key thing again.
By the way, yani Maybe I'm stupid. I don't know.
No,
but
you're not. No, you're not.
I couldn't.
Trust me, you're not. Yeah.
I couldn't understand seed and temperature.
Yeah. Do you understand the difference between a random answer or a different answer? And like, do you see the value of wanting to get the same answer every time?
Like what? No.
Like, do you see a scenario where you would like the model to give you the same answer all the time?
No.
No. So imagine you are asking the model if that sentence is negative or positive.
Okay.
If you ask it to be creative, maybe sometimes it's gonna say positive, but it's actually a negative question.
Yes.
So you wanna make sure that the model is gonna pick the same answer as often as possible.
Does anyone need some help?
So it depends on me. It
So
depends on my.
if you set these two things,
Okay.
if you set a seed, it doesn't matter what number, just set one number, and you put temperature to 0, you increase by a lot the probability that the answer will be always the same.
Okay.
Just think about it like that. Don't worry about it.
Seed defines it. What about temperature actually?
Temperature-
Is it the same with seed?
No, temperature goes from 0 to 20. It has a range, so it can be 0.1, 0.5, 0.5555555. So it's from 0 to 20. It has a range. These are integers. Seed is only in the. Do you know what an integer is?
No.
Integer is 1, 2, 5, 10.
Yes.
No point.
Yeah.
No 3.5. The temperature goes from 0 to 2, so all the numbers in between, all the real numbers in between.
What does it just provide me?
If you go with 2, so this is a parameter, it does not provide you something, it just changes the response.
For example, I just set seed 50.
Yes.
And temperature 1.
Yes.
And I set another seed 50 and temperature 1.2.
Okay.
The answer will be different.
The more you increase the temperature, the more likely it is that you will get a different answer. So if you put 1.2, you make it a little bit more likely that it will give you a different answer. Slightly different or more different, it doesn't matter.
If I put a higher, for example, I put the first one 1 and the second one 15, it will be.
It doesn't go
really
15, it's 0 to 2.
Sorry.
Yeah, no worries, no worries. 2 is the max.
2 is the max.
Max creativity. 0, 0 creativity.
The difference between if increase.
Think about it as creativity.
Okay.
Think about temperature as creativity.
Okay, I get it. Yeah.
2, maximum creativity. Model, be creative, do, run around, do whatever the fuck you want. 0 is be very succinct, be deterministic.
Yes.
Don't be creative.
Okay.
Try to play with this.
Okay, thank you very much.
You're welcome. Okay.
Answer 0.9 answer. It's the same but different.
Can I? Do you mind if I sit? Don't worry. Oh, come on. Thank you so much. So, okay, but it says mixed to both cases, right? The sentiment of the text is mixed. So 0.9 is not a low score. It's somewhere in the middle. So it's a little bit to the less creative, but it's still quite high. I would set it to 0.05 or 0.02 or even 0 if I wanted to get the exact same answer. So try to put it to 0. And also set the seed. Do you know how to set the seed? Would you like to do it?
Ne yazacağım? Kaç yazacağız? 0 nokta. Şöyle yazacağız. Ha,
Bravo.
seed.
Any number. Your year of birth, whatever.
0. Seed.
Remember, you need a comma after the temperature.
Kaç yazalım? 3 mü yazacağız?
At the end, after the 0.0, you need a comma. Yes, a comma. Not a full stop, a comma. Yeah, virgül. No, it's 7. She did 7.
Ha, 7.
And also you need to set the same seed as well.
7 virgül. Sonra seed'i de 4 yaptım.
The 4. Yeah. But I think seed is with small letters, not capital. Maybe it will work. I'm not sure, but I think it's.
Küçülteyim mi?
Yes. Try to run it together. We are all asking it now. Look. Does this make sense? Still, it can go lower. 0.07 is higher than 0.01. So if you run this many times, sometime you will, eventually you will get a different one. But with smaller temperature, you make this probability very low. It's unlikely that you will get a different answer.
Which one is better?
Depends on what you want to do. So if you care for the answer being always the same, you need a very small temperature value. If you don't care so much about the format, the style, the many words it uses, you don't care about that. In the task we will do later, we will focus on absolute determinism. Like, we want to be sure that the model is as deterministic as possible, because we need that. I will show you why. There are also cases where the format of the answer matters for you. Maybe you want the answer to be separated by a comma. So you want, let's say you're asking for, actually I'm going to say it to everyone. Is that okay? It's a good idea. I want to say it to everyone. Is that okay? Do you mind? Okay, thank you. I'll just say it to everyone. Has anyone done it? Has anyone played with this exercise and done it? Okay, for those that have done it, but generally for everyone, I want to say something. So you can change the prompt to ask, instead of only the label, some sort of confidence about the value as well. So you can be like, classify the sentiment of the following text as positive, negative, and neutral. And then provide a confidence score from 0, so an integer score, confidence score, from 0 to 10, from 0 to 100, okay? Respond with sentiment label, comma, and confidence value. Does this make sense? So you can try to play with this and see that the model will give you the label, comma, and the confidence score. Sometimes we want the confidence score because we want to focus on the sentiments for which the model has been very confident about, right? But what this will also do is the following. It will also make temperature and seed matter more, because you will see that if you don't set the temperature, you might get the same label all the time. But the format of the answer that we are requesting with the comma might change. But programmatically speaking, the format of the answer really matters. If we ask for a comma-separated thing, we want it to be comma-separated. We don't want it to have a hyphen or first the confidence score and then the label. So try to play with this and the temperature and see if it, does that make sense to what you asked? Yes? So temperature, so don't think about it whether the answer is correct, but think about temperature also impacts the format of the answer, which for whatever you're doing programmatically matters for the next step. I don't think this point landed perfectly, but think about the format always being important. So even if one word is different, can impact what we are doing later downstream in the task. Okay, the next annotation or the next thing we want to do. Okay.
With the temperature, sorry.
Yeah, go ahead.
With the temperature, it was like, I think set to 0.9 at first.
Okay.
It gave me a confidence score of 80.
Okay.
And when I set the temperature to 1.9, it gave me a confidence score of 90.
Okay, what I want you to try to do is ask it the same question on the same sentence with a low temperature and see if the confidence remains the same. Run it 2 or 3 times with low temperature. Let's see if we can make it, if we can test if its confidence is stable, if its confidence is normal. Sorry. So if you go back to the Colab notebook, you probably are gonna see this message here that the runtime disconnected. You need to reconnect to it and redo all the steps from the beginning. At least the installing of the libraries and setting up the client. So you go to the text annotation line here and you install OpenAI again. Come again?
Key 2?
Yes, the key again, the importing of the libraries. The key remains the same, but you have to redo that line. So we import again. We also set up the client with our authentication key. And after you've done that, we will continue with text annotation here on a data frame.
Make them understand something. Okay, but it's not like.
So, one important thing here. Some of your colleagues noticed and asked, why are we doing one by one this sentence annotation? Why, one, do we do it one by one? And two, why don't we just copy this thing, this prompt that we have here, our sentence, go to ChatGPT, paste it here and hit enter and do it there, right? I mean, what's the point of doing it programmatically if we can go to ChatGPT and do it there, right? One by one. Well, imagine if you had a data set of 10,000 rows that you want, 10,000 sentences that you want to annotate with the thing you want to annotate. In here it's sentiment, but it could be, I heard many things here in this room. It could be toxicity, it could be irony, it could be many things. So it obviously wouldn't be efficient to go to ChatGPT, paste one, enter, wait for the answer, take the answer, put it in the Excel sheet that you have, then copy the next one, so on and so forth, right? That's, I suppose, obvious, right? So, by programmatically accessing the API, we get the chance to do it in thousands or anyway many observations of our data without having to do it on our own one by one. So how do we do that? Some of your colleagues suggested that I put all my sentences. So in this exercise, I put all these 5 sentences here inside the prompt, and I ask labels for all of them in the prompt. I hit enter, and then the model reads all of them, calculates a label for all of them, and it returns 5 labels, right? That's one way to do it for sure. As we discussed though, with some of you, this is not the most efficient way to do it. Because as the prompt, first of all, as the prompt gets larger, the model does less of a good job in disentangling the sentences, disentangling the texts, and doing a proper job in identifying the correct label, okay? So you're making its job much harder by confounding what it has to do with more text. Remember, they can imitate humans, but they're not as good as us. They cannot disentangle sentence by sentence in order to do this task. Still, with the 5 sentences, for some of you, it worked surprisingly well still. I argue we don't have to do it, but if you add 15 sentences and you run it multiple times, no matter the seed and the temperature, it will start creating mistakes, right, in the labels and the scores. So by adding more text, we increase the probability that more errors are going to come. So how can we do it? So can anyone explain here what a for loop is? Anyone confident enough? Yes? Well, no, not you, because I know you know. Someone else would like to explain what a for loop is? Feels confident? Yeah. Try.
For each item on the list, it repeats a command.
Right. So a for loop is a structure in Python that allows us to do the same thing on a series of things, all right? apply the same function, the same pre-processing, the same whatever we have on a collection of items, on a collection of objects in our Python environment. Okay? So instead of us every time pasting the text, hitting enter, taking the response, putting it somewhere else, we can write a for loop that we write this thing once, and then we ask the for loop to go through all of the documents and do the same thing again and again and again and again on its own, in the for loop. Does that make sense? Yeah. So imagine if we go now to text annotation on a data frame, you can click on this play button here. Well, actually, let me make a small change. I know everybody has created a copy now, but we actually need this thing here. So if you can add this thing here after clone. So -- branch space YADESA _ capital WS 26. Can you add this to your code? Come again? No. Just make this, before you click play here, add this thing here. Anyone's having problem understanding what I'm saying here? So is everyone in text annotation on a data frame? So on the left side, text annotation on a data frame? Is everybody here? Someone has problems being here? Okay, so here you should be seeing a cell that looks like this, right? Everybody has this cell? Okay. Instead of running it here, please after the clone, add this thing. Type it with your hands. -- branch space YADESA _. Does that make sense? Yes. Anybody doesn't understand this? Okay. Come again? Yeah, it's Winter School 26. Yeah, YADESA _ Winter School 26. I should have made it simpler. But yeah, it should be in the text anyway. So click on the file here, on the file button here on the left. You will see that there are no files, only the sample data. When we click on play, you don't have to know how it works so much, but I have put some files in a repository online. And when you click that, you will get your files here. You will get these files here. So see, LLM workshop will appear here on the left. Worked for everyone? Yes. Okay, so now if you open this button here, you will see some files here with which we're gonna work now. So we don't have to upload it from our computer. You don't have to share. It's like a sort of easier way to do it. So I want you to run this cell now, which does something very simple. With pandas, it's gonna read a CSV with this path. Anyone wants to guess where this path is? It's where? Is it on my machine here on my Mac? Great. It's this file here. So if I copy the path here and I were to put it here, it should be the same thing. I'm pasting now. Well, it's content LLM, but it's the same thing. You don't need the content. It's not necessary. Okay? So I'm asking pandas to read the CSV in this path. This is a CSV file. Everybody knows, well, anybody that doesn't know what a CSV looks like? Is everyone not familiar with what a CSV file is? Can raise your hand. You know, comma separated values, right? So try to run this. This is an example data set. This is a pandas data frame now, right? You remember a pandas data frame from second day. This is basically Excel in Python, in a way. Every row is one observation, and every row has values in its columns in our data frame, in our data set. Right? So this data frame that I ask you to import now has 20 rows. You see 19 because the first one has a 0. That's always in Python, remember that. So there are 20 rows. Yes?
I get the error. Yes. I think, yeah, I need to import panda first.
Good job. So when you go down to the error, what does the error say?
It says that panda is not that
Right. So you need to go up. And here we are importing pandas as PD. So remember to run this cell again. But that's the spirit, right? You go to the error, you read the error, and you figure out what the problem is. Guys, we have time. You can interrupt me, you can ask questions. Don't worry about it. Okay? So everybody has this file, right? Yes. So this is 20 questions from the South African Parliament. And we have an ID, unique ID for that question, the actual question itself, the text, a salutation about the MP making the gender, basically we can have the gender here of the person making the question, the name of the MP, the party that they belong, and also some manually annotated labels here, which we'll see what they are. These manually annotated labels are these 21 policy areas categories. They come from the Comparative Agendas project. I don't know if you're aware of this, maybe the political scientists are aware, but they are a group of people that decided to create a set of codes for policy areas that can be used to systematize the analysis of policy documents, of political science documents, okay? So the task that I had to do, and this comes from our paper, I spoke to you about this paper in the introduction. So we had 100,000 parliamentary questions from South Africa, and we wanted to annotate for policy category because we wanted to see which party speaks about which policy and more, like what's the share, and compare it with their manifestos and see if a party said we're gonna do a lot about the economy, if they try to do a lot about the economy by asking a lot of questions. Does that make sense? I mean, broad terms, that's what we do. We also looked at geographic representation and other stuff, but right now this is the task. So imagine 100,000 parliamentary questions we wanted to annotate for policy category. We were two co-authors, we could have split them 50,000 questions each. It would take, I don't know, a couple of weeks, maybe more, of our time of not doing anything else and just annotating questions, and eventually we would have done it. Or we could have hired students. Now, depending on the institution that you work for, sometimes it's easier, sometimes it's harder. But instead, we decided to do this annotation by using an LLM. We decided to ask an LLM to do this annotation for us. So let's try to do it together. So the policy areas are like macroeconomics, health, agriculture, etc. Making sense? Cool.
Can you just remind me the part at the top where you have you're opening the file and there's R. So what does that part say?
This one?
Yes.
Yeah.
There's R on the right side.
Yeah.
What is that R?
That's read. That stands for read. Yeah. This is a TXT file. I mean, there are other ways to read a TXT file, but we're using the open function and then the read. This is from this library, the OS, which is operating system, and it helps you manipulate files. So when you read or write a file, you're right. Thanks for reminding me.
So you're opening for reading only.
Yeah, I open to read this. Yeah.
So that it doesn't change anything with it.
No, but because I put it in an object, now I have it in this object. I can do whatever I want with this object, right? So I can change this object, but I'm not changing the file in my computer. Yeah. But now this object now is in Python, is in my environment, I could add words to it, I could remove words to it, I could do whatever I want without impacting the actual CSV file. The TXT in this case. It could be read and write, RW, it could be other stuff as well. Yeah. So, anybody needs help? So, we have the prompt here that we devised at the time. And the prompt reads the following. You are a classifier of policy areas referenced in parliamentary questions in South Africa. Assign a policy area to each question. You can only assign one area per question. Don't justify your decisions. Only use areas that are in the below list. And then I also paste the list here, which comes from here, right? So this is the thing here. Don't worry too much about why I do it with these F things. This just allows me to play with this file, make changes to the file, and every time I make changes, it doesn't impact, like it directly gets fed in here, so that I don't have to type everything all the time. But just to show you, if you run this, and you see what this thing now contains, you will see that it's the entire prompt up to here, plus the 12 after the colon, all the 21 policy areas in one string, as if it was one thing. Make sense? Right? Yes?
Maybe you say that I miss it, I don't know. Instead of writing these prompts, let's say in Gemini or in ChatGPT, we are using here. What is the reason? Because of the string? Okay, because we have the seed here and then it will not miss anything, translate anything. What is the reason?
So what you're saying is what I said in the beginning, right? Why don't I take this thing, right? And go to ChatGPT and ask ChatGPT to annotate here.
I understood that because we are kind of decreasing the possibilities and get rid of the hallucinations. But we cannot give the comments here and then prompts here so that it do the same thing here, or it's not possible?
It's super possible. It's super possible. But you have to do it one by one. Sorry. The way you change the sentence here, you hit enter and you got a response. You took the other sentence, put it here, hit enter, got a response. You have to do it manually in ChatGPT, Control-C, Control-V. Enter, get the response. Imagine if you have 100,000 sentences. Are you going to control paste everything?
So we cannot put in one Word document or PDF document. It does read.
It does read, but it's not going to do it as consistently and programmatically as if we do it programmatically, with the for loop that I will show you now. Okay, there is no comparison to a clear for loop going one by one. You can never trust a model reading the entire document even. Just to save resources, the model is going to read up to the 5th sentence maybe. And it's just going to generate the rest out of its head, let's say. That makes sense? Huh? It's too bad. But not the way we're doing it. The way we're doing it is much better. We're approximating deterministic answers.
No, I also understood why you are using Python.
Now?
Yes.
Great.
Otherwise.
No, I really mean great. At least you're not going to go home and say, why the hell do we need Python? Like, who cares about Python anymore? So, let's not dwell too much on this cell. This is just a function definition, so something we can call again and again and again, that does very simple things. It just does what we were doing here. I'll just copy this cell. You remember this cell, right? Yeah. You remember what we were doing here? Setting the temperature, the role of the system message and the user message, choosing the model, right? You remember how we were doing this? You did this a lot in the break. So this function does the exact same thing. It specifies a model. It has the messages for system and user. It has a seed and a temperature. It also has a thing called max tokens, which we haven't explained, and I think I should very briefly do it here. So another parameter here we could work with is called...
Excuse me.
Yes?
Why the seed is 575?
Can you take a guess?
No.
Because it really doesn't matter which number it is. It doesn't matter. I could put a 3 there. I could put 1,000 there. I could put 1 million there. As long as it's an integer that is consistent across all my calls, as long as I use 575 always, that's what matters. It doesn't matter which number I use. I could use my age. I could use my age. I could use my mother's age. I could use my mother's year of birth. It doesn't matter. Just choose one number and stick with that. Does that make sense? Well, yeah, easy, yeah. So max tokens is a hard set limit to how many tokens the model is going to produce in its output, in its answer. If we set this to 3, the model is going to start generating tokens one by one. When it reaches token number 3, it doesn't matter if it has concluded its sentence in its head, in its circuit. What matters is that it reached the max token number and it will stop there. So even if the sentence sounds like Yanni went to, it will stop it there. It doesn't matter for it. It produced 3 tokens, that's enough.
And
so
why would we want to limit?
It's a way for us to limit the production of tokens so that we don't pay too much, and that we forcefully make the model just return 2 things only, 2 tokens only. Force it to predict 2 tokens and that's it. Okay?
Jan, did you just write this, Max? Because we didn't have this before.
No, you didn't. I just write it. Okay. So I put a comma here, and I added a new argument as I would have done, like seed equals 14, comma. I'm putting 14 on purpose. It could be whatever, right? Okay, doesn't matter. Sorry for that. Right, does this make sense now, the max tokens? And why I put it here? Okay. So back to the function, we have max tokens here. And by default, we say max tokens is 10. So here in the parentheses of the function called query GPT, so we are defining a function here called query GPT that contains everything in these 2 parentheses. Well, no, sorry. We're defining a function here that contains everything after the colon and up to here. But again, let's not dwell too much here. It's the same thing we've been doing so far, just in a function. And we have 2 things here, session prompt and prompt. This is where we put the main message, and this is where we put the prompt. So here goes the you are an annotator of blah, blah, blah. Or we want you to annotate sentiment, blah, blah, blah. And in the prompt goes the actual sentence we are going to be annotating. So let's try to do this. First of all, let's look at data I location 0, 1. So this is like X and Y in our data frame called data. 0 line, first column. So remember 0, 1, 2, 3. This is column 0, this is column 1. This is row 0, 1, 2, 3. So if I do 0, 1, it's row 0 and column 1. It's like coordinates, right? So when I do ilog 0, 1 and I run this, you get what's the content of that cell in that row of the data frame. Are you following me? I mean, you don't have to say yes if you're not, right? Good. So, in what way is the process to establish A, technical and vocational education and training centers, and B, new colleges or college campuses, the same as the process to establish universities? Let's say you had to annotate this question, parliamentary question, for one of the 21 CAP categories, comparative agendas categories. What would you say this was? You have the categories here. Okay? Everybody agrees? Environment.
Macro.
It's about quality.
So what's the verdict?
Education, I think.
I mean, we have to at least as humans reach a verdict here, right? If we are going to ask the model to do it for ourselves. I think it's education. I don't think it's environment, but I don't know. We can debate if you want. So I think it's education. So let's call the function query GPT that we just built here. And inside it, for prompt, we put the first line here of the data, which is this thing. So I copy this and put it here. Then I put a comma. Then I put the actual prompt that I built here. No? And then I choose the model, which is GPT 3.5.
If I were to create that function, I would have chosen the second one to be the user prompt, and the first input to be the
Good point.
system.
We can do that, yeah.
It
So
would be easier to remember.
I will do this then. I will put it here. So prompt is first, session prompt is first, prompt is second. And then also here, when I call the function, I will put this second, right? Thank you for that. This is better? This makes more sense?
Actually, it's easier to remember since we have started like that from the beginning.
So what this query is going to do now, when I hit play, is going to do what we did so far, just one more time. It will take the prompt and our sentence, send it to GPT 3.5 with a limit of 5 tokens, and get the response back based on the prompt that we created. Okay? Hopefully, here, we are going to see one of the 21 CAP categories, because remember what we are asking the model, right? You are a classifier of policy areas referenced in parliamentary questions. Assign a policy area to the question. You can only assign one area per question. Just don't justify your decision. Only use areas that are in the below list.
But first, you need to run the function again.
Yeah, you're right. Good catch. See, and we get education here. So the model correctly assigned education out of the 21 classes we had to this sentence. This might sound trivial, but trust me, it is not. With any previous machine learning algorithm and model we had to predict labels like this with 21 classes. So it was easy before to do, is this email spam or not spam? So 2 categories. Is this positive or negative is also 2 classes only. But 21 classes classification is an extremely hard task for older machine learning models. But LLMs can do it in an extremely efficient and really high validity way. So now we are going into the loop phase. This is the key. We've been working all day to go to this. Try to pay a little more attention to this, like focus your cognitive powers just for a little longer. We are in the data frame, I'm just creating a new, so just to explain a little bit. Remember the data frame, right? This is the data frame. What I want to do now, write a for loop that goes through all the rows one by one, takes this sentence, feeds it to the function that I've built before, send it to the API with a prompt that I built, and get an answer. Then I get that answer. What the fuck?
Add it as a column.
Good job. And then I get that answer that I got, and I put it in a new column here as a value here on the top. Then the next row, get the value, and I get and put it here. Does this make sense? Yes. No? Who said no? So, where should I take it back to? I mean, ask me something from the beginning. So Python is to import libraries.
I mean, since we got the file, and then how we ordered the code in order to make the loop. I don't know how we got here.
Is this box clear?
I suggest you create a pipeline, like show her what we do, certain diagram, like pipeline, how does it go?
Okay.
It would be easier to grasp.
We got this. The idea now that I have a data frame and I want to do this for every line here, does that make sense? So this is my data set and I want to know the cap category for all of them, right? What I did is I created a prompt that does this. Does the prompt make sense? So the prompt is the same as this thing. Classify the sentiment on following just positive, negative, neutral. I just define a new prompt here that does the thing I want to do now. It's not about sentiment anymore. It's about policy areas. So this prompt, I hope, is going to do that thing. This is the prompt. This is what it looks like. It's just a string, just a text. Okay, the function itself is a bit complicated, I understand. Sorry. Yeah, this is the for loop. I think there's something wrong with the internet connection here, but I mean, let's not focus on that. So what I'm doing here now is I'm creating a for loop. Remember what a for loop is? The same thing. So always query GPT in here. So 1, 2, 3, 4 steps inside the for loop. So these are inside. So these are inside the for loop. So 1, 2, 3, 4 steps are gonna happen for however many things are inside the for loop, inside the data aittir object anyway. So a for loop just goes through a list of things. So in this case, the list is just the data frame, is the rows in the data frame. For some reason doesn't want to stay open, right? So the for loop I wrote is going to go through all of these rows one by one, take this sentence, send it with my prompt that I just wrote to OpenAI API, the way we did it before, just like not manually anymore. It will get a response back, take that response and add it to a new column there as a new value. Are you sure? Does it make sense? Anyone else has a question?
Do we need to know the technicalities of all of the details of the equation?
No. You might as well come to this for loop directly. Instead of data, just put the name of your data frame. Instead of updated prompt, you put your prompt. And you choose a model. And that's it. But let's run it here on the slide, and then in the exercises part, I'm gonna all help you do this with your own data. Yes.
Before
the pipeline. Bravo. So when I run this, I've also added this progress bar. So you know now, for all the 20 rows, one by one, sends the answer, fetches the answer, puts it in a column. Next row, takes the sentence, sends it to the API, takes the answer, puts it in a new value, in a new cell in the last column, okay? And it ran 20 rows in 8 seconds, okay? So now ideally, if I look at my data again, if I open data again, I should have a new column on the right with the values that the model decided. Education, urban planning, social affairs, so on and so forth.
Is that wrong?
This is where you say, whoa, again.
Yeah, 90%.
It's not about the 90%.
Yeah.
It's about that in 8 seconds we got 20 annotated sentences, even you guys reading them all one by one would take you at least, I don't know, 2 minutes or something. And deciding the value as well that you want to put there. So now we just, with a script of, guys, I mean, honestly, this is like 30 lines, okay? If you go home with Gemini's help and you understand what each line does, you have a script here that can, I mean, you can swap data with your data set with 100,000 lines, swap the prompt with your prompt, and have a data set annotated like this with a new column within, I don't know, a couple of, maybe an hour or something. For me, this is extremely exciting. Like, this is something we should be cheering for. Not literally, but you know. So, indeed, there is a mistake here. Or at least, maybe not a mistake, but like a discrepancy, a disagreement. Huh? So this second line, manually we said spatial planning and public nature, and the model decided with urban planning, which I feel like they are very similar. There's another one. Yeah, okay. So we are using GPT-4o. I argue that if we go with a higher model, maybe, we might get a better, like a more equal agreement thing.
Can you try?
Yeah.
5.2. On the result, it says 3.5, by the way.
Yeah, because this is the column we created. I can change the name of the column to whatever I want. I can name it Yanni, just to show you that it doesn't matter, and a question mark, okay? Just you will see, but now I also need to populate the Yanni column, not the old column. And I run this again. Oh. So max tokens is not supported with this model. So see, we're gonna start to read, being able to read the model. So for 5.2, there's an unsupported parameter, max tokens, that we have in the thing. So we need to use max completion tokens instead. So instead of that, I'll use another model. We can go to pricing here and go with 4.1.
4.1 will be much different from 4.
I can increase the volume.
It's okay, it's okay. Thank you so much. Thank you so much.
Which of these code lines gives you the progress bar? Which of the code lines give you the progress bar?
TQDM. So by wrapping this in TQDM, I get this really nice progress bar, right? I mean, you need the progress bar if you're working with a longer list of flows.
So it doesn't look much different, and for the column we have GPT 3.5.
I haven't run it again. I haven't run it yet.
Oh, yeah. No,
Now transferred labor. When you have another disagreement.
Well, wait. First of all, also another change here.
Yes.
And energy remains. Well, let's go back to this. We assume that the gold standard is the manual annotator. We assume that what I annotated, this quickly done 20 lines dataset, is correctly annotated. But as we were talking before, whenever you do manual annotation, and if you want to publish a paper with manual annotation, people are going to be like, okay, what's your inter-rater reliability? How many people annotated this data? Like, did they agree? On how much? On how many? What are the disagreements? So, first of all, we need to establish an actual gold standard, right? That is 100% correct. We can test this now. We can check if they are similar or not, and we can decide if it's urban planning or spatial planning, if it's labor or transport. But I don't think there's value to this, because the point is that you understand that there needs to be a validation step here, right? And it might be that also the humans are making a mistake. In many cases, in what we did, especially with more complex cases, because the annotator gets tired, the human annotator gets tired. After a while, cognitively, you're not as efficient. So maybe we had false positives that the model found out. So in some cases, the model was doing an even better job than us. Not always, though, and depends on the task.
Is there a way to see what the sentence is like?
Yes, there is a way. Can anybody take a guess on how we can check that sentence? So imagine there are coordinates. Has anybody played Warships? That game where you say and you say B6, C1, oh, you hit my ship, and the rest? That's coordinates, right? X and Y. We can think of a data frame with X and Y. So this is row 0, and this is column 0. So which coordinates would this be?
0, 0.
Excellent. Which coordinates would this be?
0, 1.
Excellent. So let's say you want to read this sentence that there is a disagreement. What is this one?
1.
Excellent. So you go to iLock. Actually, it's here because I guess this comes up a lot. So if I run this now, data iLock, by what date does her department envisage that the white paper on human settlements will be finalized? It's quite ambiguous in my eyes. It's not entirely clear if it's urban planning or spatial planning. I don't even know what the difference is, to be honest. I don't even remember. Yes?
In the case of the AI that you just produce data annotations, how we can prove they are valid and reliable for the paper's purposes?
Okay, so I want you to be creative and try to answer this question before we actually do it. So, thank you. So you have a manual column here with labels and my column here with the model's labels. Can you think of a way for me to compare this and get some metric, some score of whether there is agreement or not? Can anybody think of a way? Not Pythonically, not in terms of Python and code. Like let's say I gave 10 papers writing something, 10 pieces of paper. Let's say I ask 2 people to write in 5 pieces of paper, different pieces of paper, 5 fruits, each of them, without knowing each other. And I start opening a paper, each paper. How would I measure if they agree or not? So I'm just calculating how many times there is agreement. So if if these 2 are the same, I put a 1 here, agreement. If the 2 are different, I put a 0, disagreement. 1, 1, 1, 0, 0, 1, 0, 1, 0, 1. I end up with a column of agreement. And I can measure how many 1s versus 0s. 80% agreement. 70% agreement. 100% agreement. Does that make sense? To compare? Let's do it. So I have a small thing here that does exactly that. Creates an accuracy score based on the manual column of the data frame, data frame, and the CAP GPT 3.5 column of the data frame. I'm comparing these 2 columns. Is it? 0.9 accuracy, so it means that 90% of the time, it's just 20 questions, right? But this is insane. Trust me, this is insane. For a 21 class classification problem, it's insane. And we are also asking one-on-one. We could ask the model, okay, provide me with more than 1 if you think there are more than 1. That is even more correct than asking for just forcing the model to choose 1. Guys, this is insane. Imagine this. on like tons of documents on whatever you want, you can swap the prompt with whatever you have in mind and annotate your data whatever you want in mind, as long as you validate.
Does that mean 90% accuracy?
Yeah. It's insane, right?
Wonderful.
Thank you.
Actual paper, what was the accuracy?
Come again?
Your actual paper, what was the accuracy?
Good question. Multi-class, so us choosing multiple. So one-on-one was 70% with GPT 3.5, but I think we used 4.0 here, so it's a better model. We got 70% and the paper got published with 70%. But we had no validation when we published that paper. If I were to resubmit that paper now, it would get rejected, test rejected.
That's a 3.5.
It says 3.5, but when we ran the model, we used 4.0 just before. So if I undo this, it was 4.0 actually. But you can try, you can play with 3.5 or whatever.
I have a question.
Please.
Just going back. When we have the question here, you say raw, and then you have question. So that means like the questions on the columns, on the 20 columns, right? That's what that refers to. And what is the
This column.
Yeah, those ones. Yeah, 20 questions that you have there. And then updated prompts are the categories that we want them to be assigned.
So
what are we exactly asking call out to do right there? That's my question, I guess.
wait, now I'm also stuck. Remember the function that we built here? This is the function that we built.
Okay.
In here we have session. I should have been using better naming sessions. I call it updated because it updates in every time the for loop runs, every iteration of the for loop, it updates the question, right? It's not the same anymore. That's why I call it updated, but I could have named it differently.
So it's the same question?
Yeah, it's.
Okay. So both of these things refer to those 20 questions we have on the table.
I don't know why I do this. I think this can be directly here. Does this make sense?
Yeah.
This is actually better. Sorry, thanks for the catch. Yeah, it should still work, yeah. I need to make a point here about cost and using OpenAI to do this. So I know this is like a roller coaster, but now I want to pull the brakes again. I still think this is extremely exciting, but I want to give you a reality check. So again, for reasons that we don't have to worry about now, here we are measuring tokens for our task. Because remember, so if I go to usage, by the way, now, usage, we have spent $4 today. But it hasn't been your thing, it has been the thing that we just did. Much of this is what we just did, what I just did. It's not your individual small querying of sentences and labels. It's what we did now, like couple of times. So the cost can come up fastly if you use a tough model, like a good model. So I need to remind you two things. Remember, we are getting charged on the length of the input, but also the output. In our case, the output is relatively small because we only ask for a label, right? Up to 3 tokens. So that's not a big cost. But the input thing, our sentences, our questions can also be very large. Could be like 5 sentences long. It's still a question, but it's very large because that's how it is, parliamentary questions. And every time we also attach the prompt to it. And our prompt is very big. Our prompt is this big. So every time the loop runs and it goes up to the API, we get charged for this. The question actually that we're asking, the parliamentary question that we're feeding, and the output of the model. We're getting charged on 3 things. So in order to estimate the cost, what we need to do, how much it would cost us to run something like this. So we need to run this tick token thing. In our case, when I run this, so this is calculating in my 20 rows of data, how many tokens there are in all of my questions, how many, it adds that 20 times the prompt that we have, and it estimates something about the output, which is like one token per time. And it says that we have 610 tokens. I'm not sure it's right, but I think it's like 610 tokens for this data set. So what I need to do now, imagine you have 10,000, 100,000 rows. You would run this and you would get 10,000 tokens, or like 1 million tokens. Then you would go to the model you want to use in pricing, and you would estimate that 1 million tokens is $10, for example. So you need to calculate cost before you click run on that loop. Because the moment you click run on that loop, it's going to start taking some of your money in that account, right? Obviously, you can just put $10, and if it works, it worked. If it was enough, it was enough. And it will annotate up to the, at some point you will get a rate error saying not enough money anymore. I will stop here in line 600 or something. So today it has all been about OpenAI and its API. But that happened because it's relatively easy to demonstrate how we can do this programmatically with OpenAI's models. Its API, although I know it sounds, oh my God, we are using the API, it's so complicated, it actually makes this a little easy. However, as we said, we are bound by these companies' decisions and policies. If for whatever reason it decides to, I don't know, cut the API access, discontinue some of the models, or even, fail as a company and go bankrupt, we cannot use it anymore, right? So we cannot do replicable science. And that's a big problem. In an ideal world, we would have two more days, and I would show you what I have on my second collab, which shows how someone can get a model from Hugging Face and run it locally. Do the same things we're doing, but with a free open source model locally. That means not paying for OpenAI, running everything on your machine or some server grade equipment, because the tougher the task, maybe you need more compute power. But anyway, you have this is available for you. You can go through this and you can read this and you can try to do it on your own. But in broader strokes, when someone goes to Hugging Face, I hope you noticed why it's called Hugging Face by now. It's because of this emoji. It's like hugging. So if someone clicks on models here, Giordano showed this before, but you have a bunch of tasks here on the left about things you want to do, about things you could do. 44 tasks here. So you have audio, text to text, video, text to text, text to image, object detection, so with computer vision stuff, image classification, we're going to do that too, text classification, translation, text to speech. So a ton of tasks that people have already built models for, and you can simply click on the model and use it in your computer. How do you do that?
And without internet? Offline or online?
You need internet when you download the model for the first time. Okay. After that, no internet needed. So if I click on a model here, there's a button here on the right that says use this model. If I click transformers, it shows you the 1, 2, 3 lines of code that someone needs to use a model like this in Python. Unfortunately, we do not have the time to go through this today. Great point. Again, remember, the way we Python coded throughout this course is through Google Colab. That is not local. It is not your machine. If you want to do it in your machine, you need something like Jupyter Notebook. In my case, in order to open Jupyter Notebook, I need to install something called Anaconda. If you have questions about this, I think you should Google it. It's very easy. But in principle, I open my terminal. That's the same on Windows. And I do Jupyter Notebook. I hit enter. Now this is locally. This is all locally on my machine. And it will open a new tab soon.
So you run the code on Jupyter, and then the machine will start.
What time should the break be? 1:30? So this is Jupyter Notebook. Does it look familiar with Google Colab or nothing at all? What if I did new Python 3? That's the version of the flavor of Python we're all using. Does this look more familiar? If I do 4 plus 4 here, and I hit command, well, there's a run button here. I get 8. This is Python coding. You can add a new one. This is the exact same thing. I can open my Colab notebook in Jupyter if I wanted to. I can go to File, Open, go to my downloads where I have it. It's not this one, but it's a .ipynb, right? It's Python notebook, interactive Python notebook. So look at this. So you can take our Colab, the thing that we gave you, and you can open them in Jupyter. But then everything is running on your machine. That means if you download Vader or some other model that is a bit more complicated to do sentiment analysis, it's bound by the capacity of computational power of this machine. So what do we do? There are versions of models that work in consumer grade equipment. I explained this in the introduction section about Olama or something like that. So please Google that. That's the solution for us. Or you get access to compute power through the university, through some servers. It's not very easy. Finally, I also wanted to say that OpenAI offers a researcher access program that you can apply for credits and funds to use its API. I still don't think it's the best idea to do our things with a closed source proprietary model. But I mean, depending on the idea that you have, it can still be extremely useful. For example, a colleague of yours has already manually annotated a tons of data, has done it manually. And it's a great idea to annotate it with an LLM again and see it as a validation exercise. Okay, my paper is about showing you that this model can do this task. So you can go ahead and do this task if you want. That would be a very, very useful publication. So you can check this out as well. Come again? Yes, it would give you access to the API for free. No, you don't. Well, you would still get some balance. I don't think it's infinite. But I don't know exactly how it works. I've never done it, so yeah. And also, quite important, I mean, they have a little bit of areas of interest to be included in terms of research. I don't think you can apply to do any kind of research. So they have a couple of things. I'll make impacts. It's mostly about the impacts of AI in social life. But I mean, you can check it out. Any questions up to this point? Are you mind blown? Okay, I want to mind blow you a little bit more. From the zero that you are, take you a little bit up. So in this folder here, I have a couple of images. The way we annotated text, we can also annotate images. So I have a folder here with images. You should have it here as well. If I double click on one and see it, it's just an animal. right? So it's a couple of animals here. It's again 10 images of animals, okay? Let's say I want to annotate them for breed, for like what's the breed of these animals, right? These are dogs, the species of the animal, right? So an image is not text. So an image requires a sort of transformation first, and this is what this cell does. We can talk about it later if everybody has a question about this. But in any case, we are encoding this image to something the machine can understand. We're taking the pixel and its arrangements to something the model can understand. And similarly, again, we are doing the chat completions things as we did before. And in this case, our prompt is what animal is depicted in this image, return only the animal species. And then I feed the image instead of the text now. Before I was feeding a question, a parliamentary question, or whatever it was. Now I'm just feeding the file of the image. I run this. Let's see the response. It says dog, and it was 0A738. So this one?
I'm getting an error.
Where are you getting an error?
Okay, I'll try again. I get it right.
Excellent. So now I annotated a question, an image for species of the animal. Because I don't hear wow again, I would like to explain a little bit what you could do with this. Many scholars are working on images of political leaders after high-level meetings. And they check what they're wearing, their facial expressions, how they're shaking their hands. They take photos of meetings of high level, like G7 or EU, whatever they do, like all of political leaders, and check how many women there are there, check what the women wear, check what the men wear, where does everybody stand, is the US leader always standing in the front or not, stuff like that. You are only limited by basically your imagination in terms of how you can use something like this in your research. Okay, I think we should take a break because everybody is very tired. Yes. Unless there are some questions, we should answer the questions first. Yes.
Do we have to change the path, the code for the path every time we want to get an answer for like the breed of dog? Because when I click on the images right there, it doesn't automatically. For example, I have an image of a donkey, but it tells me dog again.
Did you change the image of the dog?
So I have to change it
Yes.
manually?
Let's do it something else. So let me show you this before we take the break, very quickly. I don't think that's fair now because I said break already. So let's take a break and I'll come back and do it later. Is that okay? All right, guys. Let's start with the last session. Hello.
What was the first part with the Bert topic model?
All right, guys. A little bit briefly, we annotated one image of a dog and we asked the model and it returned the dog. I have a little script here that goes into this folder called images. I could name it something else. So you can upload here another folder of images and name it whatever you want and swap it there. Then swap the prompt of what you want the model to annotate and just run this line of code. And it will do one by one the annotation as we did before. We'll take the picture, turn it into something the model can understand, send it to the API with a prompt, and get the species back. And it creates this data frame where on the left we have the file name inside the images. So every row has the file name, and then the response from the model. Remember here, we get the animal depicted is a Doberman something. Remember, I didn't put respond with species, I didn't put respond with one word. So let's try to do it, respond with species in a maximum 3 words maybe. Let's do this. I could also specify with max tokens. And I click run here. See here we have seed, we have temperature, it's exactly the same thing. So now it's running again.
Sorry, what did you change?
So I went to the prompt, and I said, respond with species in maximum 3, okay, nothing actually, in maximum 3 words. So I'm gonna run it again then. So in about 8 seconds again, it annotated 10 images for the species of the animal. And now we get, in the first file, which is this one, well, sorry, what? No, so 3D is the first one, so the order is a bit different in how it sits here and how you went through that. So this is a Doberman Pinscher. So E6. Does anybody knows what a Holstein Friesian cattle is? Well, it looks like it's this. So we are annotating for animal species, but we can be explicit as what we ask. Maybe we can specify a pre-specified list of animal species that we want the annotation to happen from. So we will not get this Pembroke Wells Corgi. What the hell is that actually? 599. Okay, Corgi, I didn't know the species. Anyway, that's on me maybe. So as I said, this script, all the scripts, and this included is for you here. So if you upload your own file of images here, folder of images here, and swap its name here, and then change the prompt to do the annotation that you want, you get an annotation in a for loop that annotates all your images in a folder into one, and it produces this data frame that you can then do stuff with. How many people are doing what or whatever you want to do. Okay? Have any question about image annotation in a folder, text annotation in general? We covered a lot of ground today. I'm not entirely sure if it feels that way for you, but you learned about a lot of things. And we have an important decision to make now. So first of all, I also had 2 scripts for today, 2 annotation documents. I am super happily sharing both of these with you to continue and play with the exercises that we have below. So I have an annotation exercise later on where you can feed your own data and try to do some annotation and validation as well. But I also have my own data set that you can download and play with here. This data set, which is an annotation exercise, so it's up to you. Also in the second script, I have things about running a model locally. So this first step, this embeddings and LLMs, this is to run stuff locally without relying on OpenAI and doing sort of the same thing again. I also have automated transcription of audio files programmatically. We have fine-tuning with the OpenAI's API. We didn't have time to do this, I was sure. But I also have translation here. So these 1, 2, 3 boxes are all you need to translate your text to whichever language you want using a service called DeepL. I don't know if you're aware of DeepL. Yeah. Anybody uses that? Okay. They have an API, and you can translate text the way you would put a text here and it would produce the answer. You can do this with an API, so programmatically. So imagine you have a data frame with parliamentary questions in German or whatever. You can feed it to DeepL, translate them into English, maybe that's relevant for you, and then do the annotation in English, or, anyway, translation has many applications, okay? And you have the script there, it's for you. So now back to the important decision we have to make. So it's 4 p.m. We are meant to be here, Sumeyye, until 5. So we have two options. And I want you to vote yes or no. If you raise your hand, you are in favor. If you don't, you are against. So in this script, I have something which I think, and Sumeyye thinks, and I think some of you people think is relatively important and useful, which is called Bert topic. Bert topic is a way to, in an unsupervised manner, you feed text to a model, and the model is trying to find structure in terms of topics. Okay, actually, relatively very, very useful. So the options for you are A, I go through this relatively fast, but you see what's possible, or we stop here and you start working on your projects.
No, A.
So who is in favor of A? I think this is a majority. So we're gonna do that, okay? All right, just bear with me, it won't last too long. So if you go back to the script from the beginning, so YADESA, anyway. So you have a little bit about, the references to the papers that I spoke to you about attention, what Bert is, etc. Let's ignore it for now, we don't have to worry about it. And the fact that Bert topic moves away from the bag of words approach that Giordano showed you yesterday, where we put everything together, we remove, we do all of this pre-processing. Like, we don't have to do this anymore. We don't have to do this with Bert topic. You could, but it's not necessary. So we install Bert topic here with this. You do not have to git clone again to get the database because we supposedly did it before, but if you want, you can do it again. And I want you to open this data from AG News. This is a small version of a 1 million articles data set that is available online for you to do tasks like this, to play around with data, okay? It's relatively old now. It's more than 1.5 years old now. So it's not up-to-date information, but it contains 1 million articles and you can play with it. This is just one super small snap of it with 3,000 rows, okay? So imagine you have a data set of 3,000 rows of newspaper articles with a title and a body, like a description is, imagine the body of the article. Yes?
We are running it, but it gives an error.
Where do you get the error?
It says name PD is not defined.
Name what? PD. So remember, you need to import pandas as PD. So where am I doing the importing? Maybe we did it afterwards. But look, I'm gonna show you. You just need to do this. That's the PD that's not defined. Right? Everybody has the data set?
Yes.
Remember to import pandas as PD. Okay? So I will continue now. So if I assume most of you have this here. So this is 3,000 rows, as I said, of newspaper articles. You also have a class of what they are about. So I can also do value counts of the class column of this newspaper data frame. And we see that 700 is SciTech, 700 is business, sports, and world, okay? I could do topic analysis per class. So what are the topics inside the world category? What are the topics inside the sports category? So on and so forth. But I could do topic analysis of the entire corpus, all 3 documents that I have in there, okay? So in terms of pre-processing, Bert topic is really cool because you actually don't need to do pre-processing, okay? We skip that, this is not necessary. The way we run it is we need these 3 lines. This is a comment. So from Bert topic, we import Bert topic. We create an object called topic model, which uses this function. In here, we can specify many things. And if you go to, so I have a link here for you in the beginning of the script. We have this, this one. Bert topics, quick start guide. This is gold. Use this to read through this a bit quickly. It has an insane amount of information about how to tune certain things to make the output a bit better, more high quality, depending on your data. How to start, what changes to make, what models to use. This is very, very good stuff. But we are gonna do like a very plain use of Bert topic today, okay? Very simple. So Bert topic with no parameters. To give you an example of what a parameter would look like, we have language here. That is, if we set to multilingual, the function automatically selects a model that can do multilingual stuff as well. Now we're working with English, so it's not really necessary. What's up?
I'm saying like it's Greek.
It's great. Really?
Greek.
It's Greek? What is?
Sorry?
What is Greek?
I said it's Greek. Like,
Great. Okay. But Greek for you? Okay. First of all, it's not Greek, but unless you mean Greek as in I cannot understand it.
No, like maybe language would be.
Which language do people in Turkish, which language do you use to say I don't understand this? In Greek we say this is Chinese to me.
French.
Really? Yes. But you have all these French words. I mean, it's so easy. Everything, like, so many words. In Italian, you say Greek, no?
We say Greek.
Yeah. So I thought you said it seems Greek to me. Yeah, okay, cool. So very simple implementation of Bert topic here. We specify nothing in the parameters. And then we create two things, two objects, the topics and the probabilities of the object of the topics. We do topic model, fit transform, remember it's a transformer, and we fit the column of the dataset. In this case, the column is the description column, which was here, this column, okay? So I feed it here from the newspaper data, square bracket, inside a string with the name of the column. So I'm feeding it the entire column of all my 3,000 bodies of the articles. Not the titles, the articles. I could concatenate body and title and feed it together. I could do that as well. Or I could do only titles or whatever I want. So let's run this. The moment you click this, it should take approximately 2 minutes to run, okay? And this is again on Google servers, right? I could opt for a faster runtime, so a more capable session with Google, with more GPU or more RAM or whatever, and that would make it faster than 2 minutes. I could introduce some parameters here to make it even faster, called GPU acceleration, for example. But we're not doing that. We only have 3,000 articles. If you had more, you would probably need something like that, or you would have to wait a long time. Actually, if you try this later on, it would be great to get some feedback as to how long it took you to run what kind of documents, how many of them. Okay? So we're gonna discuss that a little bit. This will take a little bit of, like about 2 minutes, as I told you. In the meantime, let's check our usage of the OpenAI API for today. We spent $5 today, overall. I think it's a lot. We haven't done nothing. Let's see what happens when you work on your own, if anybody of you decides to continue using this. But it's very expensive, so we need to think about this a lot. Is everybody running this in the meantime? Yes. Cool. Should be done soon. Come again?
The time is increasing and not decreasing.
Where is it increasing? Yeah, it's counting upwards. It has taken 1 minute 53, 54. Yeah, it's counting how much time it takes. Finished for you? Well, faster session than me. Google gave you more resources. Even though I have a pro account and whatever. They don't care. Can you raise your hand when it finished for you?
So here it's working with the JSON file. Has not been transformed.
Does it?
Yeah.
No. Where did you see the JSON? It could be a JSON, eh? Doesn't matter. Depends on where you get your data. I got my data in a CSV file format. You could have gotten it in .txt or docx or PDF. You just have to transform, yes?
So yesterday we learned about pre-processing data.
Mhm.
It does without pre-processing data. So
It is still doing it. The steps are there, some of these steps are there. You are just not seeing it. You don't have to do it manually, but it's happening. So you need to be aware of them. Let me show you in a moment. Finished in my case as well, I think. Oh no, still running. The hell? Everybody had 3,000 rows, right?
Danny, where do you see 3,000?
So open a new code. Just type the name of the data frame. What is the name of the data frame? Newspaper underscore data, and run that cell. And you tell me how many rows there are. Scroll down. It's on the left side. I don't want to put you in this 3,000. Okay. So it ran for me as well. It took 3 minutes this time.
So what exactly Bert model can help us with
Let's see what it does. This is Bert topic. It's not Bert. Bert is the model, the language model behind it. And LLMs are an even larger version of a Bert model. Okay, but topic modeling with Bert is just uses a previous iteration of a language model.
But it's free.
But it's free and it's doing something specific, which is topic modeling. Models topics out of the data. Let's see what it does. So if you do topic model, get topic info, you get a data frame again with all the topics. And what information you get here is that the model identified in these 3,000 documents 58 topics. Yeah. And it chooses the most common words for every topic. So topic 57, the last one, is about motors, jobs, workforce cut. 57 is about limited, Dow Jones, I guess, Australia, Zealand, Bryant, Kobe, Judge, sexual, Google initial offering, JPO. So this is like some financial stuff. Hurricane, Florida, Francis, Charlie. Does this make sense? The model is it identified 58 topics in this data set of 3,000 articles, and it specified some titling of those in a way, okay? So we can also get topic information for every article in our dataset. So for every one of the 3,000 articles we have, 3,000 rows, for that article, we get the topic that the model suggests is the most prominent in that article, the name of the article. So I don't know what that is, Najaf, Cleric, Sheet, Assad. And the article is about Iraqi delegates from Reuters. And it also gives you the probability, like the confidence of the model that this topic is in that article.
what is -1 in the topic?
Which one?
The numbers.
Yeah, okay. So -1, so yeah. When we look at the topics here, the 53, 58 topics, if we go all the way up the first topic always is they call it garbage topic. It's like nonsense topic. And you can see that it has words like the, in, to, of, and, for, on, that, as, said. Do you remember what kind of words these are? Bravo, guys. Good job. So we did not remove stop words in this case, and the model itself identified that there is a topic, a collection of words that do not carry meaning, and they count that as -1. So this is like a garbage topic. It's to be dropped normally. So we focus on 0 and afterwards only. So we actually have 57 topics, not 58.
No, actually 58. Actually 58 because there is 0.
Bravo, you're right. Oh, but no, sorry. Actually 57. So 59, right? Yeah. 59, then 58. Okay, you're right. Sorry. We can also visualize these topics. Just a simple line of code says topic model that visualize topics. There are some parameters, but I'm not gonna discuss. Topics that are closer together, if they exhibit similar word distributions or co-occurring patterns, even if they do not share identical words. So here we have a cluster of topics about Australia, India, Test, cricket, England. Woods Round Championship lead Tiger Woods, I guess it's golf. Athens Olympic medal, gold Olympics. Madrid, England champions, Arsenal, Real. These are like sort of like sports topics that are similar. And here we have economy, deficits, some sort of financial about Google topics here. Palestinian, Arafat, Yasser, Gaza, Israeli, Israel Strip. So it shows you a little bit the distribution of the topics in a semantic space like Giordano showed you yesterday, like the embeddings. This can be very useful because you can see if in a corpus of articles, things are concentrated in one region versus the other. So imagine the following scenario, like you have, so for my line of work, for my research, I wanted to see if common ownership in Greece of media houses meant that media outlets had less content plurality. So if the same owner owned 2 outlets, I hypothesized that these 2 outlets are going to be speaking about the same things in the same way. Okay? That's the impact of ownership. It's a common thing, and the problem about ownership concentration in the media. In Greece, it's a huge problem. So what I would do is I would check the content of all, let's say, websites that I scraped. I would get all their articles, and I would check if the same 2 websites that belong to the same owner, if they have topics that are in the same area versus some other outlet which is somewhere here, okay? And I would compare these distances. If the distance is higher, it means that they are more distant in their content. If they're closer, it means that they share more similar content. Yes?
We had a question, yes, I asked this question. So, does it have a limitation when it comes to polymorphic words like sound, or is it better than that? Like this model, I mean.
Sorry, I forgot about this. Anyway, sorry. These models now are better than the ones we saw yesterday to calculate embeddings. So these are now trained on this bidirectional thing that we showed in the beginning. So they are much more capable of dealing with polysemy of words. So multiple meanings in the same word. Does that make sense? This is also very cool in my eyes. And extremely useful, especially if you're trying to do some exploratory analysis of documents. So a colleague of yours came before and asked me, okay, let's say, so in my scenario, before of annotating the parliamentary questions, I knew the labels that I wanted to annotate with. Let's say I just got my hands in the data and I'm not entirely sure what I should annotate for. This is a phenomenal way to do exploratory analysis of a corpus that you've never seen before and get some initial understanding of it and how it's organized, right? We can also do some bar charts about the topics and the words, how common they are and how important they are. And I will stop here. I can also do a correlation of the topics with each other. So which topic is more correlated with which one. Anyway, the code is here for you to explore. I don't think we should dwell too much on here. One important key thing is that there are hyperparameters here we can set, parameters. And I'm leaving these things here. So more things to check about, sorry, one more thing. We can look at a specific topic and its top words. So topic 49, for example, is about this. And we can also get the most representative documents of this topic. So this one, and this one are the most representative documents in our corpus about topic 49, which has these title keywords, let's say. And it makes sense, right? It's sort of obvious. It's about Venezuela, Caracas, etc., right? So here I have a couple of things that people that work with Bert topics should take a look at. Unfortunately, they are a bit beyond the scope of what we are doing here. But one important thing is that there is some parameter tuning that you can do at the start when you run the first Bert topic command that sort of impacts the output that you'll have. It's very crucial in order to increase the quality of the topics that you get, so that they are not overlapping too much, or that they are not too little, too few, and over subsuming semantic meaning from other topics, other categories, right? It's not always easy. The thing is that before Bert topic, we had to do this manually with something like latent directly allocated LDA or structural topic models. We had to manually specify to the model, okay, now find me 10 topics here. Find me 20 topics here. We would compare some metrics, we would run it a million times and compare like, you're nodding, like crazy stuff, insane, like very bad stuff, like very hard to do. In this case, you don't have to do that much parameter tuning, but there are still some things that you can tweak to increase the quality and affect your output. So it is magic, but to a certain extent, because you still need to have some input manually. And obviously validate it at the end, assign labels, or etc. Any question about topic modeling?
Labeling topics.
Any other question before Dr. Sumeiya's question? Super clear, right? Easy. Ready. You're ready to use Bert topic right away. I'm sure. Yes. Yeah. And you can run it in your Jupyter notebook, not even Google Colab. It might take a little bit more minutes to run in your machine, but it will be very fast too. Any other question? Okay, let's go to Dr. Sumeiya's question. So what she asked is, okay, the model itself is providing me, sorry, where is it? The model itself is providing me these sort of titles of the topic, which is the number of the topic and the three most or four most important words that the model identified for each topic, right? In this case, there are more words in this topic, but the four most important are baseball, Expos, Montreal League. So for topic 44 has this title. What we can do now is we normally manually need to annotate these labels, these topics with a label, with a title. What is this topic about? This sometimes requires domain knowledge. You need to know what you're talking about. Maybe you need to have some idea of what the data is. You can also ask an LLM to annotate this for you. Let's say you had 10,000 articles, not just 3,000. Let's say you had more. You would end up with more topics here. If we had 10,000 articles, it would be around 110 topics yesterday that I tried. So, okay, annotating 110 for label is a bit harder. Maybe you can ask an LLM to do it for you. Is that what you had in mind? Mm-hmm. What did you do when you used Bert topic?
I was connected to ChatGPT through.
Okay.
I don't remember the code.
Okay. Like, how did you label? No worries.
There is a way of, like, from Bert topic to connect to OpenAI's API.
Yep.
And then use it.
Yeah, you can also use LLMs in the beginning of the process of using Bert topic to calculate the embeddings that Bert is calculating here automatically. You could do it with a better performing model too in the beginning of using Bert topic too. So in the beginning and the end, you could use LLMs for sure. Yeah. There are many cool things you can do here if you check the documentation. Also, in terms of visualizations, there are many things you can do. Parameter tuning, as I told you here. I don't think we have time for the rest. I think we should stop here. Yes.
Can you look at this, how to transform this audio files to
Yes.
transcribe interviews?
Yes. So,
It's not going to take
who is working with interview data, audio files that they would like transcribed? No. Many people raise their hand. Like, how are you transcribing them?
But not in English, languages other than English.
No matter the language, I don't care about the language. Like, who is using some audio file with people speaking and transcribing them?
Before it was manual, like transcriber.
Who is, by raise of hand, who is listening to the file and typing down?
5 years ago.
A couple of years ago, I did it.
Oh, well, let's talk about now. Okay.
There's a program, Black Hole.
Black wall.
Black Hole.
A black hole. Okay, I don't know it.
It is some kind of making the voice inside of the computer. So I was opening the Google document and opening the document, so it takes the transcription. But 2 years ago. Yeah.
Okay.
There's also some AI tools.
Yeah, like transcriptor.
No, there are AI tools that
And
you
there was
can
like a big
upload the audios to them.
And then they just do it.
Anything else? Any other tool? Uniscribe? Transcript?
Transcriptor.
You are getting to more state-of-the-art stuff now? Who said that? Excellent. State-of-the-art. State-of-the-art means that's the best we have for doing what you want to do. The model is called Whisper, and it's from OpenAI, again, but at least this is open source. They don't charge for this. So if you type Whisper OpenAI, so you will get something like this. They have a test file.
Miniature motorcade of micro machines. Each one has dramatic details, terrific trim, precision paint jobs, plus incredible micro machine pocket playsets. There's a police station, fire station, restaurant, service station, and more. Perfect pocket portables to take any place. And there are many miniature playsets to play with, and each one comes with its own spec.
You get the gist. Oh, very fast speaking thing. Let's show you how good it is, okay?
Special edition micro machine vehicle and fun fantastic features that miraculously move. Raise the boat lift at the airport marina, man the gun turret at the army base, clean your car at the car wash, raise the toll bridge. And these playsets fit together to form a micro machine world. Micro machine pocket playsets, so tremendously tiny, so perfectly precise, so dazzlingly detailed, you'll want to pocket them all.
I don't even know what it is.
Micro machine pocket playsets sold separately from the Louvre. The smaller they are, the better they are.
Well, at least we got that. The smaller they are, the better they are. This is just a demonstration of how it works, but this is not how you use it. Go ahead.
It's working in different languages.
Yes, so it's multilingual. It's open source, so it means you can run it locally and with sensitive data like interviews. Interviews are by default sensitive data, right? It's a person speaking to you, granting you their voice and speak, so you should handle the data with care, not upload it to ChatGPT and get a response back, right? So Whisper can only be accessed programmatically. That means with Python. don't be disappointed immediately. So here in the script, I have audio transcription with OpenAI's Whisper. So you can open this at home and try to play. It also identifies multiple speakers. So that's called speaker diarization. So if there are two people speaking, it adds a label on who is speaking. It checks the bitrate of the voice and it figures out who is speaking differently, right? So very cool stuff. But let's make it easier. No programming. I think I showed you this in the introduction sector. There's a tool called Buzz Captions. There is a Windows and a Mac version. The Windows version lies in a GitHub repository. It looks like this, so don't be afraid of it. It's legit. And you download it here. So no, this is for macOS, for Windows. You download it here. So github.com, but don't do it now. We can do it later. The app looks something like this. Again, open source. Anyway, my Mac is, I think it's getting tired as well. So one, it's open source. So I download it for free. There's no cost to it. I can shut off my Wi-Fi connection and it works offline. It has multiple languages. Well, now it opened. Okay, so this is what it looks like. So, but to give you an example, let me see if I have this file. Look, I know this file is in English and it's not going to be too impressive.
Hey there, this is a quick and silly video to allow you to experiment a little bit with the process of transcription on YouTube.
Okay, so this is actually a video from YouTube with which I show how people can extract the audio from that YouTube file and then transcribe it, okay? But this is just the audio file, the .mp3. So you need .mp3 or .wav or M4A files. So 1, 2, 3 types of files. So you just click on the plus sign here. This is a wrapper. So no, I'll explain afterwards. So I select the file and then I choose the kind of model that I want it to run on. Whisper is good. And here I choose the type of model, the size of the model. So one sort of thing that we bypassed here is that, is this too small? Yeah, I don't know how to zoom here, but anyway. So
the other boxes from Jupyter, is it?
The thing behind it?
Yeah.
It's nothing, it's irrelevant. It's all irrelevant. This is Buzz, only this window. Doesn't seem legit because it's tiny. What's your?
It's the application. It's the app you downloaded.
Yeah.
I'm now just on the web page and I can't see anything.
No. You have to download and install like any other app. I just skip that step so that I show you how it works. Okay. So when you load a model, you need to specify the language. When you not load the model, when you load the file and you want to transcribe, you need to specify the language. In this case, it's English. You can also leave it on detect language, and it will detect the language on its own. It has that capability. Yeah, but we will do English. It's better if you specify the language if you know it, okay? It's a bit more helpful for the model. And then you select the size of the model. So one thing we sort of skipped a bit about when we talk about LLMs is that size matters. So there are models that are a bit larger than other large language models, okay? So if a model is very, very large, it means that it's gonna be has more performance, better quality of responses, but it also means that it takes longer to run. It takes longer to compute answers, okay? So that's the trade-off. Do I go with a high performance one and wait longer, or do I go with a smaller one and it's faster, but I might get a little bit less performance? When we talk about a language like English, which is a language with a lot of data outside in the world, we don't care so much. We can go with Tiny. Tiny will do a good job. I'll go with base here just to check, and I'll hit run. It will take about some time. If I were working with a low resource language, a language for which there is not a lot of data in the world, like Greek is one of those languages. Turkish, I don't think it is, because a lot of people type Turkish online, maybe not so much as English, obviously. Arabic is also not a very low resource language, but it's definitely lower than English. So depending on the language you're working, French for sure not a low resource language, I'm just saying. So depending on the language you're working with, maybe you need to experiment with larger models and wait a little bit longer to get a better response. This thing is just a wrapper. It's just a front face for Whisper that is running in the background. So it's just that someone wrote the Python code for you and put a little thing here with buttons so that you can use it in a more intuitive way. But you can do all of this programmatically in Python as well. So this completed now in 30 seconds, and if I open my something, now I don't remember. Maybe in the documents. Yeah, I mean, we can also see it sort of here. Hey there, this is a quick and silly video to allow you to experiment a little bit with the process of transcription on YouTube. All I'm looking for you to do here, so, you know, very high quality transcription of the document. Okay, it's English, it's not very impressive, I understand, but I use this a lot for Danish. It's a tool I suggest to Danish, and Danish is a very, very low resource language. The country has only 5 million people, okay? And they only speak it within themselves. Nobody speaks Danish. I'm certainly not going to learn, I think. It's a very, very hard language, but anyway. So it's amazing in Danish as well. And I know it's amazing for Arabic, and I know it has worked very well with Turkish. So try to work with this. Remember, all of this happened in my machine. Nothing left my computer. I could have done it with the Wi-Fi shut off. It doesn't matter. I only need internet the very first time I open Buzz to download the first Whisper model that I'm working with, okay? Because that is online and it gets downloaded in my machine. But if you feel like you want to experiment, you have transcription with OpenAI's Whisper in the second notebook collab that I gave you today, okay? So when you go home, you can play with that as well. It's not that much of code. Well, a couple of boxes, yeah. Any question about transcription? Is that useful? Yes.
Maybe it can be like stupid, I'm sorry, but...
There's no stupid question, don't worry.
Is there any way we just extract someone's all speeches from YouTube? Do you know anything about it?
What does speeches mean?
Like interviews. but the interviews in different channels, not one channel.
Yeah.
We want one person's interview.
Yeah. Well, you need to work with the YouTube API, query, search for, ask for that name of the person you're working with, and try to see how many videos are going to come up with their name on, assuming they are interviews. Then you inspect the data, see if they are actually videos of this person doing interviews, and then you do all the rest of the steps. The problem here, and in many cases of the questions that I've gotten today, is where do I get data? So we can talk about what to do with data all day long, but the number one thing is getting access to good data that A, is representative of the thing we're talking about. Because, okay, your colleague here asks for interviews in YouTube of a person. How can you be sure that we've gotten all interviews of the person unless the API specifies that when you search for this term, you get all the videos about it, which I don't think it happens, right? Yeah. So remember, data quality is key here, it's huge. Yes?
Just an IR question. So there is a theory, like securitization theory in IR by Olevi, but it's just, can we use data to assert that theory is like supported by data?
This is a very abstract question.
Theory testing, binary data.
Yeah, but again, you have to figure out of a data set that makes sense for that to answer that question, and also how you're going to ask the question to a model, to an LLM. It's not straightforward. I cannot tell you, yeah, you can do it like that. But be creative. Figure out a way. Think of a way.
How about data analysis? Whether they are interviews or questionnaires?
So what do you mean? What do you have in mind? So your colleague asked about data interviews, data analysis with interviews. What do you do with them afterwards? So the moment you transcribe an interview, you have a text file. Now it's text. We've been analyzing text for 5 days now. Well, 4 days. All the things we've done today, you can do with this transcription now. So let's say you participate in meetings. Every day you're in a daily meeting with your staff. You transcribe that, you take an audio recording of that. So you have thousands of files of recordings. You pass it programmatically through something like Buzz, and you get the text out of them. Now you have thousands of text of transcriptions, so you just have to analyze it. You can do Bert topic on them. You can do some annotation on them. Who speaks? Why? Is the first speaker speaking more than the second speaker? Do women get to speak more? Does someone scream more than the other? What vocabulary do men use versus women? A million questions you can ask.
Semantic analysis?
Yes?
So can be done.
Yeah.
Question for you.
Yes.
Maybe you have experience with this. Do you know of any model that also like kind of annotates the volume, like kind of the
Speech. Yes, for sure. Yeah.
So you can get if someone is screaming at you.
Yeah. So many people are working with parliamentary video recordings of the sessions, and they check. So first of all, they identify who is speaking, which party do they belong to, government, opposition, what the topic is, are they a man or a woman, and then they check how much clapping is going on in the background, when, at what point. They also measure the volume of the voice and in what points it gets raised to make what kind of points.
But this is like all whisper or?
No. Whisper is just transcription. Yeah. Whisper is just taking. I don't think I can explain it now well, so let's not explain. But it's about transforming sound waves into words. So it's a bit different. Yeah.
Is this here?
Yes.
Thank you. I may have missed this, I apologize if I do. When we did the Bert intertopic distance map visualization, is there a way I can figure out how to, for example, zoom in to show?
Would you like to ask Gemini? I also don't know. Yeah. You had a question?
What you said to Andrea, is it contained in the Python notebook?
No.
The answer to that? No.
You were interested in that?
I mean, somehow, but it's fine.
Guys, I just want to say something. I mean, I don't know if it's clear after these 5 days of being here in this room for so many hours, but it's about you now taking some of this and being inspired, ideally, of how you could potentially use this. I mean, I don't even know how to do half of the stuff you have in mind. Like, I have no clue, honestly. Like, you have to go out and figure out how to do. What I hope we have showed in sort of a cool way is that certain things are possible, and maybe they are not extremely hard. They are like some lines of code with the help of Gemini and ChatGPT. You can also do them yourself. I hope that's an argument that passed. I don't know if that was your goal too, Sumaya, but yes.
I wondered, can you make a kind of sentiment analysis the data that the topic model is?
Would you like to elaborate? We've done sentiment analysis and Bert topic separately. How do you think they can be combined? How do you think they can be combined? Yeah, so you can see if one topic is present, what is the sentiment then? So when this media outlet speaks about sports, is it mostly positive, negative, or neutral? When it speaks about the Israeli-Palestine conflict, is it mostly positive, negative, or neutral? When it speaks about Trump, is it positive, negative, or neutral? So you do topic analysis, you say each document has this topic first, and you say when this appears, what's the sentiment? Make sense? That's how an idea I have now that we could do. Anything else? Shall we, Sumaya, there are 20 more minutes in this slot. There's no time to do something else in my eyes. So we can either take an earlier break or work for 20 minutes on some of the things, or we can answer questions on your machines. What do you think? Yeah. Let's do some group work for the next 20 minutes.